A big welcome to everyone. Thank you so much for making the time to join. We are really excited to have everyone here at this colloquium that we are running on exploring human potential in education, training, and research. And we really don't think there could be a more important topic at the moment that we should be discussing with what has happened recently in the field of AI and its impact, obviously, on all sorts of sectors, but particularly on the areas of education, training, and research. My name is Craig, and together with Manoj, we are facilitating the session, and we are joined by an amazing panel of people, which I'll talk more about in a moment. So we really are excited because we have real experts from education to industry and business leaders to academics and researchers across the range who have given up their time to be here today. So we thank all of them, and we thank all of you for attending, because we're really excited to start to unpack these things, because we're living in an era where we have experts, as we've always had. We have experts in AI, we have experts in technology, we have experts in education, and that's wonderful. But it's this confluence of all of these things that becomes the issue. How do we apply these AI tools, these technologies to our education, or our training, our research? What does it mean? How does it work? And it's the experts in that zone that we're really missing. And the only way we can get that is by bringing everyone together and having a conversation around it. So that's what we hope to do today. So our theme, as you can see, is essentially focused on education, training, and research. And just to set a little bit of background before we kickstart with our first session, is I did a quick Google Trends look at how the term AI has been searched. It obviously gives you an indication of what people are interested in and what's happening. So there you can see this this graph that shows you the interest essentially in AI. And it slowly was increasing over time, but there's two interesting parts. One is a little beep here, and then we've got this jump at the end. And I was like, oh, what was this little one here? And that was way before I was born. I mean, that was like 2012. So I mean, I don't know what that was about. But anyway, I went online and saw that in 2012 there was an article in the Guardian that reasons to be cheerful in 2012. It's the year we'll start talking to robots. So there was obviously a spike in interest around that time, and maybe one of our other AI experts can tell us why. But yeah, I don't think we did much talking to robots. If you've worked with any of those bots that organizations have, they're just terrible. But there was obviously a lot of interest, and then it dropped off when that really didn't happen, and there was just the AI researchers in the background doing their thing. Until, obviously, I've now put a second search term in, ChatGPT, and you can see how now the two have now spiked together. So obviously the release of ChatGPT from OpenAI caused this massive surge in people's interest in AI, and all of us here sitting in this colloquium today. It really has maybe opened our eyes, and as we will hear later from people like John McLoone, who will join us second session, who will talk about some of the work that's been done in AI even prior to this, from their perspective in Wolfram Alpha. The work has been there for a while, but it's come out into the public eye, obviously, more recently with what's happened with ChatGPT. So there's this great and exciting interest. Right, well, that's enough from me. We're really excited to hear from our panel of experts, and we've got some amazing panelists, as I said. Now, I didn't know all of these people are just super amazing. They are just incredible and leaders, as I said. Now, so I didn't know how to arrange them, on the photographs. So I thought, well, I know. Obviously, asked ChatGPT to do this for us, and so it did, and it then just ordered it in terms of, I think it did it on its first thing was surname order. I thought, no, come on, ChatGPT, give me something creative, order them in some interesting way. So eventually it came back and said, okay, I've reordered them, and I've ordered them based on the length of their surname. And I looked at it and what? Well, I don't know. That doesn't make sense at all, which actually is an interesting insight, that this was the order it gave based on the length of the people's surnames, which is actually not correct, which is interesting because that's part of the whole concept of where ChatGPT is, particularly in AI, and how much do we trust it? What can we rely on it from? And as I said earlier, we'll see a presentation from John McLoone later, where he'll actually talk about this specifically from Wolfram Alpha side, while that sometimes is more accurate when it comes to these more mathematical things. But that aside, we have an amazing panel of people, as you can see over there, and they come from various backgrounds and come from various skill sets. So we really do thank them all for making the time. And as I said, thank all of you for being here. Right, so it's time to get our brains thinking and see, where is this all leading? What is the future? And obviously we can't tell. We've just started this journey, but we really do need to start thinking about where it's all headed. And so on that, I'm going to stop my share, and seated with me here already, you can see is Bilal. He's on my, it's very confusing as to what's happening on my left here, I think. And then on the other side of Manoj is Shaun, and Shaun is going to be kicking off our first session. And Shaun Dippnall, he is a tech entrepreneur, and he's also the founder and CEO of ExploreAI. And that's a company that provides customized AI solutions to businesses. And I'm sure he'll tell you a little bit about that. But his whole business is thinking. He wakes up, he thinks about AI, but particularly how AI can make a difference in the world, which is really exciting. So I'm going to now hand over to Shaun, and the format is going to be each of our presenters will do a short 10-minute presentation. And so if you've got questions, you can hang on to them, or you can put them in the chat, because we will pick them up. And then after they have done that, so we'll have Shaun, Professor Bruce Watson, then Nithen, Naidoo, and John McLoone, and then we will have a 30-minute discussion. Right, so handing over to you, Shaun.
Hi, everyone. My name's Shaun, the founder of ExploreAI, recovering actuary. Very quickly, we build AI applications at scale. We work across 3 continents, building applications in the retail, telco, water, and financial services sector. Where we started, and alongside that, is we teach AI at scale across the African continent. And that's the next 10 minutes, is how we teach, our philosophy and mission. In that process, we hire the best into our applications team to build applications. So it's quite an interesting combination of assets we've got. Let me now spend 10 minutes explaining the education side. So firstly, headline 1, there's 26 million developers in the world. Inside there are data scientists and data engineers, and only 700,000 are African, right? So last time I checked, that was like 2-3% are African, whereas 40% of the global population are Africans. There's a massive disconnect between the sort of workforce in Africa and what percentage of those become developers. This is another way of saying in 20-30 years' time, the majority of the global workforce is going to be African, yet currently, a small fraction of those are learning tech AI skills and being employed in that sector. If we look at, I think this is a South African graph, if we look at our education system, it's just failing, right? I mean, of the 100 people who start grade 1, a small percentage get through matric with a high mathematics mark, and then a small percentage of those get a STEM degree, and we have massive unemployment. I think one of the worst in the world, and one of the most unequal societies as measured by the Gini efficient, right? So you step back, massive global workforce, huge opportunity to contribute globally. A small percentage and fraction are playing in the sort of fourth industrial revolution, and our education system doesn't seem to be working, right? And that is where ExploreAI was founded, and our mission is to teach those skills at scale in an affordable, creative way across the continent, which then has huge benefits for individuals, communities, families, etc. And what we do is we teach in innovative ways that are very different to the traditional sort of 100-year-old education model. So let me spend the next 5 minutes talking through what that actually means, right? So firstly, we've been doing this for about 5 years. We've taught tens of thousands across the continent. What we're really proud of is that over 90% of our students complete the course and then get a high-paying job as defined by $24,000. That's an incredible success, right? If you look at African universities, a small fraction of those, a lot less than 90% get jobs, and the starting salary is a lot less than $24,000. And that's a different discussion. But this course and solution is around teaching employable skills that are in high demand, where there's a route to employment that's fundamentally sort of improves the sort of individual's outcomes. What makes us quite unique is we've got the application arm, right? So while we practicing in the real world, we take that into the curriculum. So this sort of tech space is moving so quickly, you can't set a curriculum and wait 7 years before updating it. Like every quarter, there's a new platform or open source tool or coding, ChatGPT pops up. So you need to be able to quickly iterate and update your curriculum to be relevant for the workforce. To touch on how we do it, so it's not sit in a classroom, learn a syllabus for a long period of time, write an exam. It's real world simulation, right? So students are always on a project, which is a sprint, which is, in the real world, you'd have a 3-week sprint. You have a problem to solve, you get put in a team, you get given material, and you got to present the solution in 3 weeks, right? Which is how it works in the real world. And you iterate through 3-week sprints over a year period, learning all the fundamentals along the way, with lots of ability to go at your own pace, and with facilitators and sort of online material. So that allows us to simulate the workforce, the real working environment, and then also to create an affordable model that can scale, which is the self-paced blended. On those projects, it's we give real world problems that we get from our actual applications business. So for example, there might be a problem in the telco space. We then take a fraction of that into the students, and we give them real world data, which is messy. It doesn't line up. You got to clean it. You got to make some assumptions. So that ability to work with imperfect data in a real world situation is very valuable, because typically in traditional situations, it's clean data which doesn't exist in the real world, and sort of easy answers which don't exist, right? Like it's working through ambiguity and grayness, which is a skill that you need to learn in our academy. I'm going to show you, talking quickly because I'm running out of time, I'm going to show you an example of the video that we might show students. So as you'll see, it's intuitive, it's interactive, it's fun, it's engaging, very different to a sort of a dull textbook. Let me sort of show this for 10 seconds.
Let's begin. In recent years, we've seen the advent of the Internet of Things and all sorts of online services. You can order food, purchase goods, and even hail a cab to almost anywhere in any city, all using the internet. Consumers are continuously generating data and huge amounts of it. The volume of data that are being generated by humans and machines continues to grow at an exponential rate. This growth has led to a phenomenon known as big data. So what is big data? Big data refers to massive and complex collection.
So that's one video, and that's quite a sort of a basic introductory video. We've got many videos across the whole of data science, from Python to SQL to supervised learning, unsupervised learning, neural networks, probably thousands of videos with tutorials alongside that, exams, so it's rich content available to the student body to move through in their own pace, rewatch, redo, automated marking, etc., right? So a really rich, colorful learning journey. Let me see if I can work this. Alongside that, there are humans to help, right? So you can go through at your own pace. We find that the top 10% want to engage with our facilitators to learn extra, and the bottom 10% who are struggling want to engage with the facilitators if they need help, and the middle 80% just sort of get on and go for it. We have a teaching body. It's I think like 1 to about 200 students. They're doing a number of things, right? I'm not going to read this, but they're there for one-on-one help. There's weekly webinars. They give feedback on the tests, announcements. So it's a sort of a rich community of help whenever you need it. We've got a frequently asked question sort of forum. There, a lot of that's automated. We're using ChatGPT to automate further the discussions and the sort of replies. So headline here, rich self-paced learning, and then facilitators there for when you need help, which is often not that much. 2 last slides and then I'm finished. 2 case studies. So we've worked with a big telecommunications company who want to build their data science capability. We've taught 500 students for them over the last, I think, 3 years. They've hired 75 of those. Other 400 we've placed elsewhere, and 25, sort of got lost. And the value to that company is huge, right? We've built them a data science team of 75. Along the course, they're doing R&D. We've generated $15 million of value in the projects the students have done. We've upskilled some of their employees, and then that 75 data scientists in that business have, built huge value for that company. Lastly, and then I'm going to keep quiet, the most exciting project we're on is training, partnering with ALX in Africa. This year, we're teaching 25,000 students across Africa our data science course. And that's a POC for a broader mission of teaching 2 million Africans across the next 10 years. If you go on the socials, you'll see this, but this is core to the mission, our scalable platform, which is cost effective with light touch mentoring, scaling into Africa and teaching, millions over the next 10 years, hits the original mission of a global workforce of, a billion young Africans, giving them the skills to succeed, learn critical skills that will change their lives, their families and the communities. So that's me. That's sort of 5 years of work in 10 minutes. Happy to take questions after the sessions are finished.
Right. Thank you so much, Shaun. To be able to get down 5 years of work into 10 minutes is very impressive. Fascinating insight into what you're doing, and I've already jotted down a couple of questions. If these don't come up, we're going to ask you about it. But yeah, very exciting to see what's happening with AI, and then I love the focus, obviously, on Africa, and these are the sort of tools I think that can start to make a huge difference in Africa. The use of AI to try and accelerate that. So thank you very much for that. Right, I'm going to hand over to Manoj, who's going to introduce our next speaker.
Well, Bruce is a professor in the University of Stellenbosch and one of the leading computer scientists, really not only in South Africa, in the world. And he's got a wealth of experience from everywhere. And, you've got his CV in front of you. But Bruce, I don't want to embarrass you by extolling your virtues for the next 5 minutes. I leave it to you to talk to us. Thank you very much.
Thanks so much. Thanks, everyone, and very much appreciated. Very tricky following Shaun's exciting talk. So let me dive right in and just tell you a little bit about the research trajectory. I hope it stimulates a bit of discussion. It will look like I'm mostly going to highlight problems in AI, and that's actually not true. I note there at the bottom of this first slide that I'm actually an AI optimist. So I'm very keen and excited about the stuff that we're doing. The aim of this a very short intro is just to give you an idea of what I see as being the problems. I've put it all onto one slide here, but I'll just quickly mention them and then go into a bit of detail and see how we do time-wise. I think it's reasonable to say that algorithms are probably the single most important invention that humans have come up with. So I say this, of course, as an algorithm nerd, but algorithms drive the decisions that we take on a daily basis, whether we know it or not, but of course now facilitated by artificial intelligence. So it's very exciting in that sense. And the quality of outcomes, whether it's driving, cooking, business decision-making, and so on, is all driven by the quality of the underlying algorithm, whether it's innate or more explicitly brought out. Quite a few of these algorithms are safety critical. So it's not acceptable to have these things have a failure mode, which is also very important. Coming up with new algorithms is remarkably difficult, but of course now we have algorithms that are creating algorithms. So this is the very exciting aspect of AI, and we knew that it was coming, but it also means that there's a tremendous body of knowledge already built up, but it's a fraction of what we actually need in the big picture. So that's the exciting angle to this, and I'll just mention a couple more of these as we go. So what have we gotten now with the arrival of generative AI? As it's already been pointed out this morning, it's not really the arrival. I mean, these things have been around even from before 2012, but nonetheless, it's really hit the news now. It's really big. So what have we gotten? Well, we've gotten a whole bunch of very cool stuff. It's worth noting that everyone's addicted to it in that sense. It's all about what can I now do with ChatGPT or a similar product as well. It has brought us much more natural interaction with apps. So instead of a lot of point and click, now we've got much more of a conversational aspect to this. So it's really lowered the human machine barrier a lot. So people involved in interface design are very excited. It's also got surprising functionality. So sometimes there's stuff hidden in there that we didn't even ask for. It's stuff that it just pops up with. It's changed our cognitive workload. So we're now explicitly offloading a lot more onto it. It's given us a lot of blue sky opportunities. So we can have domain-specific versions of these AIs. We can start dreaming about what we can do with these things. So that's all fine and good. And of course, it's a very much a dynamically expanding functionality. So what you thought you had today, tomorrow it'll be able to do even more. It typically is doing things that we want it to do, so it's growing in those specific directions and adapting to the interactions that we've had with it already. It feels, at least to us, that the construction of these systems has been painless, so they've just magically arrived there. Of course, that's not really true. So we know that under the hood, companies have done a tremendous amount of effort building them up, and we'll hear from Wolfram later on about that as well. And it's left us with a really interesting legal and ethical tangle in terms of plagiarism and of course copyright and creative outputs and so on. So what is it that we like about traditional classical software? So I just wanted to briefly mention this. Most of these things are actually lies that we know how to do this about software, or that we regularly do this. But in principle, we know how to get this done if we actually put in the effort. So classical or normal pre-AI software, we know how to specify systems. We even know how to give a formal specification of a system, writing it down and knowing what it should be able to do. We've got predictable construction of the system, so we can do this using correctness-oriented ways of doing that. We know how much time it's going to take to build a system, how many resources, how many programmers, and so on are going to be needed to build a system. It's inspectable, so we can actually go into it and we can look under the hood how it works. We can understand the system completely. We can build it in such a way that it's secure from privacy leakage, and therefore we're reasonably assured that we're not going to have legal problems with the POPI Act or GDPR or something in Europe. It's got predictable running behavior, so we can have it explain to us, or we can actually explain for ourselves why it came to a particular decision. We know something about the running time, the resources that it's going to use, how much memory, how many computers, how much cloud storage it's going to need. They're modifiable. So we can add new features, we can compose them with other systems, we can debug them and go in there and actually change something if we've discovered there's an error. And they tend to be behaviorally static. So a long time ago, it was already recognized that having systems that modify themselves, so-called self-modifying code, is actually a terrible idea. So they're behaviorally static, and that actually turns out to be a good thing. So those are all of the things that we claim that we love about classical software. And how does this hold up with artificial intelligence? And I just throw this up there because this highlights for us some of the things that we still need to tackle, if of course these are things that are desirable in the long run. So on the right panel there, you can see the things in particular that are yellow highlighted and struck out are the ones that we're not going to be able to do in the immediate future, and these are then some of the research foci. So one of them is, can we specify beforehand in a formal way what the AI system is going to do? And it turns out we don't have the mechanisms for that yet. So very exciting area for someone to do a PhD, and lots of people already working in that as well. Predictable construction. We know how to build systems like ChatGPT in terms of the amount of time it will take to build them and the amount of computing power, but we don't know yet how to do a correctness by construction approach to that, where we build it up from the specification and we're assured that we've come up with something that we want. Building something that's inspectable. Can we actually look inside it, understand how it works? We don't know how to do that. It connects, of course, to the notion of explainable AI. So we don't yet know how to look inside a system that's run and then be able to understand really how it came to that particular output or how it came to that particular decision. So that actually is also remarkably difficult. Security from privacy leakage. We don't even know how to do that. The people interacting with ChatGPT or similar things are not really assured that the system's not absorbing all kinds of things from them. So this is a very important thing as well. Modifying the system after it's been built up. Do we know how to debug it? Go and fix a little bit inside the system. Also something we don't know how to do. And lastly, these systems are not behaviorally static, meaning that there's no way we can actually really stop it from growing and advancing. And that's actually, as we said, one of the real appeals of the system. So I'm at the time point, and I'm just going to show you what the rest of the slides look like, because I hope this stimulates in the discussion later in some of the questions. So there are known solutions in classical software. There are people that that look old because they actually did a lot of this work in classical software more than 5 decades ago. So very important stuff. And I'll leave it at that. So thank you very much, Manoj.
Thank you very much, Bruce. Thank you. I'm sure there'll be lots of questions at the
Yeah,
discussion. There were lots of interest in the poll that I put up about ethics. So let's see what happens.
yeah.
Great.
Yeah, thanks, Bruce. Too. Fascinated. I just see this thing of we don't know. It's like we've got this black box of AI that we've sort of unleashed, and you thought, who would have ever thought we'd get to the place where we've got this tool and we don't know what it's doing. I mean, it's very, exciting, scary, and interesting. Maybe it's all of those and other sort of adjectives as well. But thank you for raising that. And I think that's why we need these colloquiums, and obviously we need the research, and we need to know how we're going to use these amazing tools. Right. So thanks, Bruce, and for that little snapshot, and I'm sure that's going to get people like thinking and get their questions ready. Right. Manoj, do you want to introduce Nithen?
Yeah, Nithen Naidoo is at the moment sitting at the Marriott Hotel, I think somewhere in Ghana. Last night he was desperately called me from Kenya, where he was stuck in the airport for 14 hours, I think, and only arrived early this morning in Ghana. So thank you for being awake, Nithen. And Nithen's the CEO and founder of Snode Technologies, which is a local South African company. But I believe Nithen lives in Vietnam most of the time when he's not traveling the world. But Nithen, welcome, and thank you for giving us your time. Over to you.
Thank you. So yeah, just a little bit more about Snode. Some context for the presentation is we're a cyber defense firm based out of Centurion, and our technology spans across 6 continents and about 5 million devices that we protect, all for governments, for private institutions, etc. And straight into the presentation. So many of you guys may be familiar with Mr. Robot. There's an episode in Mr. Robot where Elliot's in this alternate reality where he's the CEO of a cybersecurity company, and he tells his client, "I've seen you get hacked." And the client then gets a big sudden shock, and he said, no, you haven't been hacked, but I ran some simulations and I saw you get hacked. And this is what inspired this presentation, well, not the presentation, but the prototype that we've built using, it's an AI-based prototype that generates simulations, attack modeling, threat modeling, and risk modeling. So typically there's 3 types of simulations. You've got physical simulations, which is probably the most prevalent for a really good reason. It's really high fidelity. And essentially that would mean you hire a hacker attacks you, and you see how your defenses hold up. The second one is like lab emulation simulation. Now, this is something that we typically do at Snode to test our detective capabilities against some form of malware or an exploit, very much exploding it in the lab and then testing our control effectiveness in the ability to detect it or defend against it. Now, simulation modeling is something that we see a little bit less. It's a data-driven exercise, but it's normally a desktop exercise that needs to be executed by an expert analyst. And really the risk, the risk is in the eye of the beholder. And that's where it kind of falls short. So it's lower fidelity than any of the other 2 models. The challenge we wanted to solve was, 1, can we increase the fidelity so it surpasses a physical simulation? The second part of it is, could we run hundreds and possibly thousands of simulations in real time using AI so that we could increasingly in real time make the client aware of their risk profile, their vulnerability landscape, the threat landscape, and help them prioritize risk. And I'll tell you why that's important in a second. I love Sun Tzu. The Art of War is a great book. You should read it. There's a piece from The Art of War. If you know your enemy and you know yourself, you need not fear the results of 100 battles. Think of the 100 battles as the 100 simulations we're running for you in a second. And the 2 inputs is your threat data, which is knowing your enemy, and your asset vulnerability data and risk profile data, which is knowing yourself. So now, what's the problem? Well, Sun Tzu didn't exist in the digital age with the 4th Industrial Revolution. I took these pictures on Saturday morning at about 3 a.m. And it's a medium-sized business within South Africa in the telecommunication space. And the graph on the left represents all the communications within that second that was happening, or close to a second, maybe even less. The graph on the top right all the data flows happening externally. And the graph at the bottom, the vulnerabilities. I'm drawing your attention specifically to, like, for example, where it says critical 78 vulnerabilities. Now, when you think about this, it's cognitive overload for a human being. And as much as our platform is, it's a big data platform, which, Craig and the previous speakers have referenced. But it's not amplifying the information provided into intelligence, right? Now, if we look at the enemy landscape, it's not much better. Interestingly enough, you've got 78 high-risk assets, highly likely attacks from high-risk sort of criminal entities that are targeting this institution in that very second. Now, don't get me wrong, the solutions are there. So we use defense to solve these problems. It's really treating the symptom, right? It's not actually helping you solve the root cause. And the thing is, the client looks at these dashboards, and it's great that they're pretty. It's great that they're giving you this data and information in real time, but it doesn't really ask the question of, so what? What's the very next thing I need to walk out of here and do? So that's the question we wanted to go out and answer, right? Wanted to see whether we could elevate this data or this information into true forms of intelligence, right? Actionable intelligence, to be precise. And the high-level methodology is, could we classify attackers' behaviors? Because, an attacker needs to get lucky once. We as defenders need to get lucky all the time. But there's a few conditional items for an attacker to get lucky. So I've got to break into your network. We call that initial access. I've got to escalate my privileges. That means I'm going from a user to an administrator. Then I'm going to move laterally to some critical data asset. We call that lateral movement. And then I'm potentially going to exfiltrate or try and extort you from that point forth. So understanding the threats, understanding the vulnerabilities in context to each other, and understanding the successful attack paths that this threat needs to follow, and then helping you understand what's the next big thing that you need to go out and fix. So the way the platform sits together is there's a correlation system. This is like natural grouping, co-occurrence, and these sort of algorithms that are helping you contextualize all these events that are all happening simultaneously within that second. Then there's a classification system, right? That's telling you, well, these components are really strongly tied to initial access or privilege escalation or lateral movement. Then there's a component which is asset and risk profiling, because you wouldn't go into rob a bank and ask the teller for jewelry the same way you wouldn't go into a jewelry store and ask for the cash in the register. Understanding what's your assets is extremely important. And then there's the generative AI part, where we design attack trees, and I'll show you an example of an attack tree, understand the attack paths and the graphing thereof, and how we can break the actual attack path by putting in some sort of mitigating or control or some form of remediation. And having expert analysts essentially reinforce this. Now, I'm going to give you an example. There's three really important things I want to illustrate in this example. Number one, on the left, you'll see an example of an attack tree. We use graphers, and that was actually AI generated. I do use the terms, I don't like to use AI, ML, cognitive computing and mathematics interchangeably. So I'm using some poetic license just to tie closer to the theme. And this is the same client. Unfortunately, it's not on Saturday night, but it's about a year earlier when we set off to design this prototype. So this entire attack graph is the output, essentially, of the algorithms. What's really impressive here is that although there's, I think there's 8 vulnerabilities that the platform picked up and 5 data assets that were affected, that red point with attack vector 1 and vulnerability 1, you fix that, you take away the entire problem statement, right? So one action, could break the entire attacker's skill chain. And just in terms of risk, what was most interesting is that database server is actually airtime. The fact that a machine could understand this, contextualize it, for those who are not familiar with the telco industry, at any given time, an AI database, an airtime database could hold anything from 20 million to 60 million rands worth of airtime. Airtime is money. The pins go disappear. It goes into the into the black market. It's incredibly hard to trace. The fact that a machine could understand that data that I showed you earlier in real time and isolate one action that you needed to follow up with and isolate a 20 million to 60 million rand risk is an exceptional result. Of course, there were some problems. For example, the predictive analytics did its job. The prescriptive analytics needed some work, right? Came up, it said, the solution's multi-factor authentication. And unfortunately, this is a point-to-point VPN, not a user VPN. With that said, I'd like to thank you for your time. I know I ran out of time there, went really quick. I'm going to leave you with the Sun Tzu quote. And I may not be there for the question and answers, but I'm going to leave you with our CTO, and he'll be there during the discussion to answer any questions you guys may have. Professor Manoj, back to you.
Thank you very much, Nithen. I know that Bruce sitting on the panel virtually on the other side will be very interested. He's a cybersecurity researcher as well, so you might get to talk to each other. Thank you very much. I know you're busy, have a busy day in Ghana, so if you can't stay, it's fine. I know you've got two other team members on the chat who are waiting to step in for you. Thank you very much. Very good.
Well, thank you.
Yeah, thanks, Nithen. Really interesting. I think one of the polls that Manoj put out there is, will AI make this better or worse? We're in an arms race here, so that'll be interesting. Maybe we can unpack that a little bit later. So these are all the exciting things, and it's amazing how we can use these tools to try and help us, as well as obviously the bad guys want to use it to help them as well. So very interesting times we live in, and thank you for sharing that. Right. Okay, so we're now on to our next speaker. But it looks like I'm frozen here. Can you hear me, Manoj?
Yes, we can hear you.
Okay, sorry, it just looked like I'd frozen for a second there. Okay, our next speaker is John McLoone, and I think John is actually here, and he is the Director of Technical Services and Communication and Strategy at Wolfram Research in Europe. So we're really excited to have John here. John, I've got your presentation, so I'm just going to play his presentation, and then we'll pick up there. So I'm just going to share my screen, and we will just watch that presentation together. And he's going to be talking on a very interesting topic, ChatGPT and Wolfram Alpha, a tale of two AIs.
Hi, I'm John McLoone. I lead the technical services team for Wolfram Research in Europe, where we do computation and data science projects for customers using Wolfram technology. And Wolfram is the company behind the online knowledge engine Wolfram Alpha, the mathematical computation system, and the computational programming language, the Wolfram language. I'm also the co-founder of computerbased-math.org, which is an organization trying to rethink the maths educational curriculum in a way that actually assumes computers exist. Now, what I wanted to do today was to talk a little bit about the way that Wolfram Alpha has approached question answering on the web compared to ChatGPT and other large language models. And this is really a contrast between the fundamentals of statistical AI versus symbolic AI. So if we start with the exciting new large language models that have appeared very recently and are still emerging as we speak, they are simply statistical models to predict what word comes next after previous words. What's exciting about them is that they are sufficiently rich in that statistical structures that they've built that the next word that follows and the next multiple words that follow can be very human-like in their ability to answer a question. The text that follows a question is the answer, or the explanation behind a statement, or generative content like writing poetry. LLMs and other statistical AIs are very good at some things, but they also have weaknesses. Let's talk a little bit for a moment about what they're good at and then what they're not so good at. They're very good at handling a wide range of inputs. We as humans are very good at language, and we've got years of experience in phrasing things in different ways and understanding different ways of putting them. And up until now, that's been quite a challenge. So if I give some kind of complicated way of asking a question, ChatGPT and its competitors are very good at turning that into simple, pithy questions. The kind of things that Wolfram Alpha would struggle on can be rephrased very simply by LLMs. They're also very good at handling poorly defined or poorly understood fields. So here I've asked it, how should I train a dog to sing? I'm sure there's no solid theory for how you train a dog to sing, but it's come up with a very plausible explanation of how one might go about it. And of course, the thing that's getting everyone excited about them is they give the appearance of really human-like interaction to the point that they could fool you into thinking they're really understanding things. So that's things like creative writing, like writing a poem or a song, or writing in a particular style, or rewriting text and summarizing it, or extrapolating on text. These kinds of things they are achieving in ways that have never been possible before. But large language models are not good at everything. Because what they do is probabilistic, and there's no real understanding behind what they're coming up with, they tend to fall down where things actually require proper understanding to achieve. So they're not very good at things like logic and rational and computational thinking. So, for example, if I ask this question of Alice is older than Bob, Bob is older than Charlie, Charlie's younger than Derek, and ask the question, is Alice older than Derek? That's not a very complicated piece of logic. And while it's come up with a nice explanation here of why it concludes that Alice is indeed older than Derek, the conclusion is wrong. And it doesn't take too much thinking about to realize that there isn't enough information to decide the answer to that. They're also generally very bad at following rules. So even something as simple as a piece of arithmetic, here I've asked it to add two numbers together, which is in ChatGPT 3. The answer is plausible, and in fact, it is correct for the first three significant digits. But if you compare it against the actual computation here that I've done in the Wolfram language, it's actually wrong. Most of the digits are just fiction. And as soon as you go to something more complicated, like here's some calculus asking for the integral of some formula, even though the narrative is very convincing about how it's gone about it, the answer is just wrong. When things start to require processes and steps that need to be precisely followed, this kind of approximate random way of assembling the words really just falls down. Also, by design, they are not intended for large amounts of information. The working memory of GPT-3 is about 2,000 tokens, so a page, I guess, of text. GPT-4 has pushed that back quite a long way to 20,000 odd tokens, but that's still, a few pages or a small chapter of a book. That's the entire working memory. Now, if you're doing anything in data science, that's a trivial amount of data. I routinely do projects with hundreds of millions of numbers, and data science, statistics, and maths are very geared towards that kind of large data processing, but large language models just really don't even attempt to take that on. But the thing that most people have been concerned about is, in the end, reliability, that they have a tendency to hallucinate and just make things up. So here's a question I've asked of GPT-3. I said, provide some data on livestock populations in the country of Turkey. And it's come up with a perfectly sensible looking essay. And I was particularly drawn to this point here where it says, based on data from Turkstat. On this occasion, Turkstat is a genuine thing. GPT has been known to completely fake references to support its argument. In this case, this reference is a real thing. But it turns out it is not a supporting reference. If you go to Turkstat and drill down through the pages of information, and eventually find the document that answers this question, you see that the sheep population is 42 million. Not the 33 million that this article claimed. In fact, all of these numbers are wrong. They're all in the right ballpark, so they're plausible, and large language models are very good at plausible. But this idea that it can be trusted because it's cited is just, both these things are, there's no reliability going on here at all. Okay, let's go now to what we've been doing with sort of symbolic AI and the way that Wolfram Alpha and Wolfram technology works. Our word for this symbolic AI is computation. And computation is really where you have defined rules of behavior for structured inputs. So if you take the example of adding those two numbers together, those are structured inputs, integers. We know what those things are, and we know the rules of behavior of adding, subtracting, multiplying, doing all of these things to integers, very rule-based. It turns out computation is a really broad area that we've been spending the last 30 years trying to integrate computation from mathematics, like theorem proving and graph and network analysis and calculus and statistics, with things that you might see more of in physics, like differential equation solving or image processing, or engineering calculations like control theory, chemistry calculations like energy bond calculations or spectroscopy, and all kinds of other areas like geo and data computations. Machine learning falls into that as well. Business things like time series and financial calculations, and even in things like digital humanities. Now, what you see on the web with Wolfram Alpha looks a little bit like GPT in that you type in a question and you get an answer. But actually what we're doing is applying a very rule-based grammar set up to the question that you ask, and turning that into a structured piece of information, like an integer or like an entity that represents a thing in the world, like a city or a person. And then we're applying computational algorithms to that, fed by live and stored data in order to generate the answer. Most of this is highly deterministic algorithmic processing under the guise of conversational AI. So what is that good at and not good at? Well, it turns out that it's almost the complete opposite of the statistical large language model strengths and weaknesses. The computation is extremely good at logical, rational thinking. So my who was tall question, we can code up symbolically as this quantifier elimination type question, and ask the question, is it true that for all possible setups there, Alice is always tall and Derek? And it says, no, it can conclude that that isn't true. It can follow rules. So here's the same calculus question that I asked before, and in the Wolfram Alpha world, we get that absolutely correct, better than any human could do. We also, of course, computation is very good at handling large amounts of information, and it's also very good at deterministic and reproducible and understandable rules of behavior. So the reliability is very high. If it can do something, it'll do it every time. Of course, our approach isn't good at everything. So the very things that the large language models are good at, that's where we tend to be quite weak. We have natural language input, but anyone who uses Wolfram Alpha knows that you kind of have to get the hang of the way to pose a question, because if you're a little bit too flamboyant in the way that or exotic in the way that you phrase sentences, or you make sentences too complicated, it very quickly can't handle that level of complexity. It's also not at all good at poorly defined or understood fields. If there aren't rules of behavior, then it can't deal with that. So writing poetry is difficult because it's very hard to actually write down what the rules of a good poem are. They're just one of those things you know when you hear it. And that kind of human-like you know it when you see it is not a good basis for rule-based computation. And they're not very good at looking human-like. It's not a case of trying to make the picture one is better than the other. They both have their own strengths. Our vision at the moment, and we're putting a lot of effort into, is to try and bring the two worlds together. Can we take the best of the large language models and other statistical generative AIs and put it together with the strengths of computation? And here's a few different ways that that emerges, and we're building out the tool set very rapidly right now to make this something that will be easy for you to be able to do yourself. So here I have the idea of computation-driven narrative. In this case, the computation is very trivial here. I'm using financial data from databases that I'm using the Wolfram language to structure into open, high, low, close values, and then I'm feeding that as the basis of a stock trading website's narrative of today's action. Now, because this is not based on the big compressed corpus of knowledge that is static and out of date from a year ago when the large language model was trained, the facts are based on computation that I've just computed, then this narrative becomes much more reliable. And large language models tend not to hallucinate when they're fed the facts as part of the inputs. They tend to use them very reliably. Another key thing that we're doing is the same kind of idea, but reversing the lead. And we were invited to be one of the first plugins for ChatGPT that were launched a couple of weeks ago, where if you enable the plugin, and you have to be at the moment on the invitee list from OpenAI to get access to the plugins, but you check out the Wolfram plugin. Now when I asked this question that it lied to me about before, what are the populations of different livestock in Turkey, you see this used Wolfram button appears. That is the large language model figuring out that this is something that we might know the answer to. It's called Wolfram Alpha, asked for the facts, got the facts back, and has now written, in this case, a much more terse narrative, but based on those correct facts that it requested. And because of the generality of the large language model, it's very good at spotting the kinds of things where the Wolfram Alpha might be able to inject some useful information. And you can always prompt it by saying, ask Wolfram what are the populations of different livestock in Turkey. And because we can compute visually as well, then adding a follow-on prompt here, make a bar chart, the large language model took the data that it had in its narrative, pulled those numbers out, and sent them to Wolfram Alpha and said, can you make a bar chart of these values? And then it's injected it back into its answer. So if we want to join together these two different worlds, one of the questions is, how do we go about that? And it turns out there's a choice that's kind of interesting. If we look behind the scenes at what happened, if I expand the use Wolfram button in our previous query, you'll see that Wolfram Alpha's ability to take more basic but still natural language inputs is the way they've chosen to communicate. So they're using English as the interchange language between the two different AIs. And this is how it retrieved the values and it got them back in a sort of list of values, but not especially structured. But when I then went on and asked for the bar chart, here it actually wrote Wolfram language code, and the code itself was evaluated. Now, a lot's been made out of the excitement of the way large language models can write code, but because code writing is ultimately one of these rule-based worlds, actually there's a limit before they break down, even though there are some very impressive examples in isolation. Sooner or later something goes wrong. But there's two things that we have here that are advantageous. One thing is that because the Wolfram language is very high level and designed to be very human readable, actually it takes less code, typically 10 to 20 times less than Python or Java, to express the same ideas, and they are higher level, more language-like ideas and less code-like, which actually makes it easier for the large language models to generate. And on top of that, we've been building feedback mechanisms that allow hints to be given back to the large language model when the code doesn't execute, to explain what the errors are and ask the large language model to try again. And you actually get sort of a loop of conversation going on where the LLM writes code, Wolfram language says, well, I don't recognize that command, that's not a valid command. The large language model corrects itself and eventually you get into something that can be executed. And these can be reasonably high-level expressions of idea. Here I've tried to describe the collapse conjecture in words, and it's written a quite significant snippet of code here to generate this plot of the waterfall sequence or collapse sequence. And finally, another big win for the integration is the handling of unstructured data. So anyone who does data science knows that getting the data straight usually is the majority of the work. And it turns out that's the bit, when it comes to data science, that large language models are quite good at. So one of the things that you can do is you can use its ability to do what's called few-shot or one-shot learning to give it examples of how you want to restructure. And large language models are very good at that. So from a code level, I can embed the capabilities of the large language model in order to make import filters very easily. So in this example, I've given a description of what I want to achieve. We're going to get the name, height, and age of some people. And I'm going to give it some examples of this is the input, and this is how I want to represent it. So I want a Wolfram language structure, and I want Wolfram language notions of quantities, and Wolfram language notions of symbolic missing data. And then having set that filter up, I can now apply it to some unseen data. And what we get back is now a computable data set where all of this has been turned into the Wolfram language structure that allowed me to tabulate this very easily. And these quantities are now proper entities within the Wolfram language, so I can do computations on them, like let's get the first person's age and convert it into days. Leveraging the built-in knowledge that large language models have about short-range structure makes this kind of restructuring of data much, much more efficient than rule-based approaches that one would have had to build up before. So we've got these two worlds, the statistical on the left, the computational on the right, and in the end, we're trying to build all of the links in all the different directions of when one can call the other to help out on the things it's not good at, in order to have the same kind of start point, natural language input or unstructured data input, and insight output, but using the best of both worlds. Well, I hope that's been an interesting viewpoint, and if you need more information, follow the links here or feel free to write to me at my personal email address. Thank you.
Right. Thank you very much, John. He's here, so we'll be part of our panel in a moment to share his insights. I've realized that I am not an AI. I really have to work on my AI skills. As I'm looking at my program, I managed to switch Serge and John around. Serge was about to go, and then John came in. But eventually, once our brain is outsourced, it won't even need it. It'll just be handled anyway. In fact, all of you will just be avatars, and the avatars will talk to each other, and we'll hopefully be in the Wally situation, floating somewhere, sipping drinks. But anyways, thanks, John. That's really interesting for that, and we will pick up a conversation on John's work. And now we're going to hand over to our final panelist for this first part, and that is Serge Stinckwich. He's the head of research at the United Nations University Institute in Macau. And we're very excited and honored to have him here. And I'm going to hand over to him to share his presentation with us. Thanks, Serge.
Yeah, thank you for the introduction, Craig. So I will share my screen and put my slides. And thank you, Manoj, for inviting me to be part of this great colloquium. So my name is Serge Stinckwich. I'm the head of research at United Nations University Institute in Macau, and I'm also a computer scientist. And before joining UNU, I was working, in fact, in Cameroon, in Central Africa for 2.5 years. And I was working with local universities on AI applications. So today I want to share some of my thoughts and the thoughts of the the work of UNU about the impact of AI on sustainable development goals. And especially I will talk mostly about the impact of large language model. And as Bruce already mentioned, and because most of my talk will be about the negative impact, I'm also, and maybe this is difficult to understand, we will see after my presentation, but I'm also an AI enthusiast and an AI optimist. So, so I will maybe start with the first slide, so about the 17 sustainable development goals that I guess you all know that are part of the 2030 UN agenda. And in my research institute, in fact, in Macau, we are working mostly on the impact, so the negative and positive impact of digital technologies and AI on these SDGs. And today I want to discuss some of them and mostly the impact about all these large language models on the society, on the world, in the large. So, and hopefully, in fact, I was after John's presentation because I don't have to spend too much time on what is a language model and what is a large language model. So maybe I can briefly remind you that these large language models are not about facts but words. So the main task is to predict the most probable word following a series of words based on them. And they are very good, in fact, when you are doing linguistics tasks. So every time you need to do auto-completion, machine translations, when you want to summarize a text, they're very good to do that. So for example, if you had this sentence, there might be different possibility to complete this sentence, and based on the large corpus that they are using, these kind of models can put some numbers, and you can build sentences like that with this kind of approach. So it's a purely a probabilistic model. So what are the risks of these kind of models and ChatGPT? So I will try to explain some of them. So I guess the first one is maybe the one that this kind of tools might pose a potential risk on some kind of jobs, especially creative jobs, like people who are doing like knowledge workers, for example. So, and maybe you have heard about this image generative AI system like Midjourney, and I guess for this kind of people who are using this, who are creating this kind of image, this kind of system might pose a problem in the long term. And even for journalists, software developers, and even maybe for academics people, it's also something concerning. Academia, so it's also maybe it's very interesting because without any domain expertise, you can start to write some scientific papers, and this might raise some questions about the future of research production. And but at the same time, there are still a number of issues, because if you have used ChatGPT, for example, and try to produce some references with ChatGPT, most of them are fake. In fact, it's completely it's like hallucinations. In fact, so it doesn't work that well for that. Education, I guess we will spoke more during the discussion about that. It's very concerning also. ChatGPT is already used by some students to write essays, and some universities try to block the access to ChatGPT, but I think this is not a good solution, because we have to accept these tools. And I guess we will have to do the same story that we have before with Wikipedia. We have to maybe try to teach and educate the students about how to use these kind of tools. What are the benefits? What are the limits? So I think we have to play here the role of teachers with students, and not try to completely eliminate these kind of tools in the education. So now I will focus more on three specific risks linked to large language models: so social cohesion, environmental impacts, and transparency. And for the first one, about disinformation and social cohesion, so I took one example, and because I'm located in China, in Macau, so I took this nice example that, in fact, this is the first incident report about ChatGPT, and this incident is inside one repository database that is very interesting. In fact, you can have a look later to this public database. this database is about AI algorithm and automation incidents and controversies. And in February 2023, there was a report that one resident from a city in China, Guangzhou, used ChatGPT to generate and announce that the city government have lifted the number plates driving restrictions starting from March 1st. So it's something that becomes viral on the Chinese social platforms. And normally, in fact, ChatGPT is not supposed to be usable in China because normally this is banned in China. So I don't know exactly. I guess this guy used a VPN to have access to this to ChatGPT. But you see that this is. And for this example, it's not really harmful, but we can imagine that in the future, more and more, you will see more and more examples of using ChatGPT to produce fake news and disinformation. So this is something very concerning in the long term. Briefly, another example of the risk that and the impact of the large language models is on the environment. So it's very difficult to measure exactly how much these models produce, what are the production in terms of greenhouse gas emission of these models, because most of them are designed and owned by tech companies. But there are some, we can find some insight and some information about these models, and we can try to make some prediction about their emissions. So I took a few examples here. This is one of the first large language models produced by Google in 2019. So BERT, and it's already a large model from that time. It's more than 300 million parameters. It has been trained on the GPU, and the training is roughly equivalent to a Trans-American flight. Another example, the Bloom, is something very interesting because this is an open source large language model produced by people in France and trained in a large computer in France, produced by the company Hugging Face in 2022. And these models, for training this model, they use something like 25 tons of carbon dioxide emissions. So it's roughly equivalent to something like 30 flights between London and New York. And in fact, it's not that much because they train it in France. And maybe you know that in France, we have lots of nuclear plants. So it's not producing that much emissions at the end. And finally, GPT-3. So there's not that much information about this one. So it's some people try to estimate, and apparently, for the training, you produce something like 500 tons of carbon dioxide emissions. So you see that it's much more heavy in terms of emissions. So it corresponds to 600 flights between London and New York. So you see that these models, this is just the beginning of the use and the training of this model. So we can expect that there will be thousands and thousands of these models used in the future, and this might they might have lots of impact on the environment also. But there are also lots of ongoing research to reduce the size and the economic cost of this model, because they produce a lot of emissions, but at the same time, they are very also costly. So it's I guess the companies, the tech companies, they will try to reduce this cost in the long term. Finally, another risk about transparency. You know that in fact most of the large language models like GPT-3 are trained on words, the billions of words that are scrapped from the internet, and since there are lots of toxicity and bias on the internet, so you have to purge the data, you have to curate the data, to train the data, and the humans are important in that perspective. So one solution to do that is to try to train an AI on labeled text, on labeled examples. So you try to remove everything related to hate, violence, etc., sexual abuse. So you try to remove this by training your system, try to find some labels, examples. And recently some journalists, some Times journalists discovered that in fact OpenAI used in order to get these labels, they use a company located in Kenya called Sama, and they use thousands of snippets of text. And employees of these companies, they have the task to read and label something like between 150 and 250 text per shift, so 9-hour shift. And these employees have lots of mental issues because frankly, there was not that much counseling and counselor to help them because they were exposed to lots of hate and racism and sexual contents, etc. And so it was quite traumatic for them. And it was not, in fact, OpenAI didn't discuss too much about that. So it was discovered by this journalist at the end. And finally, it was so traumatic for the employees that some had canceled all this work for OpenAI a few months after earlier than planned. So you see that this is also an important issue related to the lack of transparency of this kind of system. Because if you want to secure these systems, if you want to remove the toxicity of the system, you need to have the kind of human in the loop in order to remove as much as possible these bad things. Finally, my last slide. So I just want to highlight. One work inside my institute. So we are trying to understand all these risks and the impact of all these risks on SDGs, and we try to find also to try to mitigate this risk. And we recently released one report. It's about gender-sensitive AI policies. You know that AI and probably large language models have a lot of bias regarding women. And so we have conducted research in 5 different countries in Southeast Asia in order to understand what are the AI landscape of these countries, and what are the impact of AI, especially on women. So thank you for your attention, and back to you, Craig, thank you.
Thank you very much, Serge. Very interesting. You raise all sorts of interesting challenges around AR and where it's going. And I was just thinking, you talk about the humans removing the toxicity of it, and which obviously raises the issue of whose AI is this, whose views is this? We tend to sit there and just believe everything it says. It sounds, the way it speaks is so confident. But there has to be humans, and there's some opinions almost built in already. So these are all big ethical things that are coming our way, which are really interesting, which we'll hopefully pick up in our panel. Now, we're just having quite a small change in our agenda because Professor Jonathan Jansen needs to get on a plane, and he's not going to have signal to communicate with us when he's on his plane. So we're going to bring him forward. It doesn't matter with everything. We'll just move down a little bit, and then we'll jump onto our conversation after that. So Manoj, do you want to introduce Prof. Jansen?
Yeah, it's my pleasure. I mean, Jonathan and I go back a very, very long time. And I know him from the days when he was at UDW, even before we became UKZN. So Jonathan is now a distinguished professor of education at Stellenbosch. But I think we all know Jonathan as a public commentator on education, very strong views. And he's going to share some of those with us now. Thank you, Jonathan. Over to you.
Thank you, Manoj, very much. And I'm going to pretend that I understood perfectly everything that was said by the previous speakers. I tried to convince Manoj that I know nothing about AI other than some of its implications for education, but very interesting stuff, and congrats on your conference. What I want to speak about very briefly is what we can expect from higher education institutions in South Africa in the wake of recent revolutions in AI, which clearly have significant implications for teaching, for learning, and for assessment. So while it is true that I don't understand much about AI, I do understand institutions and how they respond to the problem of change. A recent book with one of my postdocs on the politics of knowledge in decolonization is in fact a comprehensive empirical account of institutional behavior in the face of a perceived threat, that threat being decolonization in the 2000s, and now, of course, perceived as a threat in higher education, the old issue of artificial intelligence, in particular, ChatGPT and other chatbots. Now, most South African universities have done very little, if anything at all, to respond to the challenge of AI and its most immediate concerns for higher education, and perhaps of all the educational implications, most importantly, assessment. Now, when ChatGPT, since late 2022, made waves, I asked the leadership of my university why the subject was not on the Senate agenda as an urgent concern. And I was met with very puzzled looks, as if this was something sort of way out there in the metaverse, I suppose. And I've asked that question of vice chancellors and deputy vice chancellors around the country, and there's a strange sort of unresponsiveness, that I would say, except in the one celebrated case, of course, at least until recently, of the vice chancellor of the University of Johannesburg, who made 4IR almost a religious kind of mantra. He never opened his mouth without saying 4IR. But that was very much something that he embodied in his own personality and vision, whether it translated into action on the part of deans, for example, heads of departments, and other things. But I think the reason why I'm met with puzzled faces is, number one, a general lack of leadership interest in or understanding of this important technological moment and its potential impacts on higher education. I just don't think our leadership is concerned about this issue, in part because if you were UCT, you're just trying to ensure that you manage your vice chancellor or the previous vice chancellor, or in other cases, just trying to manage your budget so that you don't go into the red, or in other cases, trying to figure out how you can game the system of subsidy optimization. But there isn't a leadership. We don't have academic leadership. We don't have visionary leadership. The cupboard is bare when it comes to the kind of leadership that says what's happening in the rest of the world and how do we prepare our universities to participate or critique or engage in these, particularly as far as technology is concerned. I find that very, very disappointing. The second reason, I think, there is implicitly an institutional awareness of the unevenness of technological infrastructure, and that therefore means a limited ability to absorb the changes in the world of technology and higher education. And that too is a reality we have to face up to here. So if you go into the University of Fort Hare, that is literally just trying to keep its vice chancellor alive and not assassinated. But in the context of the pandemic, I mean, there's a whole set of universities that were effectively cut off, rural universities in particular, from their students because of the lack of access to basic things like, electricity in the rural areas and all of that. So while the more established research universities could move seamlessly from, face-to-face to emergency online to fully online instruction, for a whole lot of universities, that was a completely strange thing. So you can imagine in that kind of conflicts, of unevenness, as I call it, that when you raise the issue of ChatGPT, you have a fairly major disinterest, to put it mildly. And so the energy around AI and higher education is therefore likely to come from professors, not from leaders, by which I mean in the Vice Chancellor's office, more likely to come from professors with knowledge of and interest in technologies of change, such as Lara at UCT or Maharaj at UKZN, but not, as I said, in the rector's office, as we call that in Stellenbosch and the Afrikaans universities, former Afrikaans. What, therefore, are the major concerns that those of us in higher education should address in the light of AI, and in particular large language models, and in particular ChatGPT? Now, the big question around the world, of course, at the moment, both for schools and universities, is what does this mean for the integrity of student assessment? That's the big question. And there's a panic, actually. You can pick up the news anywhere in the world, and there would be, in any given week, a spotlight on ChatGPT and the integrity of assessment and so on. And there have been a couple of approaches so far that I find interesting. The one is try and beat the technology at its own game. I call this expert detection. So using the very same AI tools, how can we detect if a student is cheated on an assignment? Now, as you know, at the moment, there is no perfect foil for doing this. And so will we get there one day in which you can perfectly predict that this particular piece of work was completed by a human and not by a machine? I don't know. But at the moment, last night, for example, watching a program overseas in which a whole lot of students were distraught because they'd actually done the work themselves, but these detection mechanisms had misrecognized the work as that of ChatGPT. The second is, of course, to put your head in the sand. I call this outright avoidance, where you pretend the problem doesn't exist. And of course, at a very simple level, this is an immediate solution, which is you bring students into a room, you tell them close down your computers and your mobile phones, take out a pen and paper, and answer this question. Now, that obviously takes us back into the dark ages as far as technology is concerned, and I just don't think that kind of head in the sand approach is sustainable, but nonetheless, it exists. And then there's a minority of people, like Johannes Cronje at CPUT, for example, for whom this is good news. In other words, there's a full-on embrace of ChatGPT and similar devices or apps because of the potential that they hold for improving existing assessments rather than trying to fight it, of course. Now, I think that trying to outsmart AI because of concern over assessment integrity is like trying to ban the calculator in another decade, or trying to tell students not to bring their mobile phones into the classroom in this decade. ChatGPT in particular offers, as far as I can see, a unique opportunity to reform an assessment regime in universities that has long been anti-educational, if not downright corrupt. I'll give you two examples. In many of our universities, assessment is nothing less than a management tool in large classes rather than a feedback loop of information for more effective teaching. So, for example, when we did the COVID women studies 2 years ago with more than 3,000 women participating, women academics, I was astounded that colleagues at UNISA were reporting in the qualitative section of the survey that they teach more than 10,000 students without the kind of infrastructure to support them, such as 100 teaching assistants or something like that. 10,000 students. Now, when you're in that hole, you don't open yourself to major discussions on innovative assessments. What you do is you generate a whole lot of meaningless MCQs, multiple choice questions that you can process through a machine just to stay sane. I have to say I understand that, okay? Even as I disapprove of it as far as good pedagogy is concerned. Nonetheless, when assessment becomes nothing more than a management tool, then you're in trouble because it cannot give you good data on how to teach, which is why you should be assessing, among other reasons. Secondly, assessment in several universities, and you saw this particularly during COVID, was an instrument for optimizing subsidy income rather than searching for evidence of deep learning. So when I assess students, and I'm not teaching at the moment, but 2 years ago, I want to know, how deeply do you understand a concept? And I use assessment in order to probe those depths or or otherwise, as opposed to simply saying, as a lot of our colleagues did, instructed by the deans and heads of departments, and I have this on record for several universities. Listen, we've just had a pandemic, or in the middle of a pandemic. Pass as many students as you can out of sympathy for the fact that they have been, disconnected from the university and had unreliable connections and all of that. Again, as a human matter, I agree with that. Find a way in which you can compensate for the lack of access to quality teaching and so on. But what does that do to higher education if the means of compensation is simply focused on making sure enough students pass in terms of the output subsidy so that your university can make money? I find that truly disturbing and obviously unacceptable and so on. So, which raises the question again, why do we assess in the first place? So that's the backdrop for my argument, my thesis, that ChatGPT might be the best thing yet to happen to higher education in South Africa. So rather than spending large amounts of time trying to determine whether a student cheated, lecturers, in my view, should up their game and ask students the kinds of assessment questions that require deep insights, rather than ones that rely on simple recall facility that is easily assembled, by the way, through the conversions made by AI tools. In the last class that I taught, as postgraduate student teachers, 280 of them, I had long lines of complaints that went something like this, and this is from fairly middle, upper middle class, sometimes very wealthy students at Stellenbosch University, who came from obviously the elite schools, and they said, Professor, this is the first time I got 0 in any class at school or university. And the reason they got 0 is because they can't think. They've been taught how to game the matric exam, which any idiot, having taught matric as a biology teacher, I can tell you it's not a mystery how to get your kids to get A's. But at university, I didn't ask the student to write down the 10 characteristics of effective policymaking in education. I required them to interpret, to apply, to personalize, to critique, and to generate their own ideas on something like efficacious policymaking for children in rural areas of South Africa without electricity under lockdown conditions. Now, that's a very different kind of question, and it is very hard to cheat on that question because of the many variables at play in the context I just gave you that requires obviously innovative thinking, self-reflection, and even a change of mind. It is also easy to detect, if that is the goal, something as artificial, if I may mix my metaphors here, that does not reflect the voice of the student, let alone the rather low-level writing skills of so many of our learners. So I realize, of course, before you tell me that assessment protocols reflect the structure of disciplinary knowledge, and so assessment in the humanities and the social sciences, given my examples, will require very different ways of doing assessment than in Manoj's discipline, which is mathematics, or in computer science, for example. But that is exactly the challenge. How do we rethink and redesign assessment across the disciplines to make teaching more effective and learning more meaningful if the word education is going to mean anything at all? Thank you.
Thank you. Thank you very much, Jonathan, for your insightful and insightful comments, as usual. We understand that you have to leave. We will, Craig, we're going to break now for the discussions. So perhaps Jonathan can be here for a short while before he has to leave. I see lots of interest in the chats here.
Yeah, thanks everyone. Thanks, Jonathan. That was absolutely fascinating. Yeah, I resonate on raise all the things you were talking about, the leaders having another set of issues and worries, and it's down to the professors to try and make this change. It is absolutely huge. But yeah, I think, as you said, the shot in the arm is one that can't be ignored. I think in many ways we ignored many things. In my own experience, I feel that after COVID, we came back and thought, well, okay, we'll put that one behind us and we can just carry on. No one will care about going online. And now you've got like 1% of the people in the classroom, whereas there was 20% attending before. And now then we get hit with this. And if we think we're going to ignore this as well, it's just a delusion. But yeah, a great opportunity to change things. Right, so thank you, everyone. We've got a little bit of time now to chat about some of these things between our various panelists. And there are various questions there. Manoj, do you want to kick off with something? Then we could just get this conversation going. I know you had some good meaty topics that maybe everyone could maybe chime in on.
Yeah, okay, Craig. I've got the chat open on my iPad here, and one of the things that has been questioned a little bit and addressed by Serge is the issue of evidence when you speak of potential bias or the risks, if you will, Serge. And there's a question of evidence. But before you answer that, linked to that is possibly the issue of ethics. When you talk of risk, and I'm sure there will be an ethical risk involved in this. And I know that Shaun has to leave for another meeting as well. The issue is perhaps Shaun is. Do you believe that AI offers the potential for true massification? My comment has always been having, and I'm sure you have the same experience in Africa, as most developing countries. We talk of the information age, and in an information age to thrive, you need access to information. And to have that access to information, you need broadband or affordable mobile data. We just don't have that, And my experience is people will turn on their data, they'll do what they have to do, they'll turn off their data. There's no time to immerse themselves into stuff like this colloquium online or things like that. So you really believe that, that we have this potential, if you will, for AI to be used when people don't have access in the first place, and how do we address that? Let's start with you, Serge, and then we can get on with the Bruce and.
Yes, I agree with some of the question asked in the chat that there is now lots of evidence, and if we see all the literature, the academic literature, in fact, and also the incident database that I mentioned in my presentation, there's a lots of evidence that there are lots of risk in different domains, and we have to understand this risk. And also with large language models, what we see also recently is that there are emergence of new risk, in fact, because we see that in fact the bigger are these models, in fact, the stronger might be the risk at the end. So after that, so we have to understand, we have to contextualize also, because depending of the countries, depending of the culture, depending of the economic development of the countries, there might be different risk that happens. And after that, we have to think about how to mitigate this risk. And this is maybe the most difficult part, because this is very easy to come up with principles about AI. And maybe you have heard about the UNESCO recommendation in the late 2021 about the ethics of AI. So it's quite easy to come up with this kind of principles, very general principles. But after that, how you can enforce these principles in real system, and this is the most difficult part, because for the moment we don't have clear answer how to do that, how to come to move from the principle to something that is more operationalized in software. So I think there is a lot of research that we should do in order to find solution for that.
Yeah, thank you, Serge. I mean, the point I think is that we are all embedded in this tidal wave, if you will, right now. And there's no time to learn and then apply. We have to do everything on the fly, so to speak. We've got to learn fast. We've got to do the research, and we've got to embrace it as well, because if we don't, we get left behind. So it is a difficult situation, but it's something we have to acknowledge and work with.
That's why just leaping in. That's why I think it's very interesting having, the academics, like, who've spoken. You've got people like Shaun as well, who are trying to do it, and we're trying to bring these fields together, because in a way, especially for higher education and even for secondary education, we just haven't been doing it like this. We've been so stuck in a way of doing it. And someone mentioned a book that I think Jonathan was involved in about how we could change schools. That's even more urgent now for schools and higher education. And I think it's maybe companies like Shaun's involved in that are trying to say, well, how are we going to do this? So I don't know, maybe Shaun, you want to just pick up on some of what Manoj asked there, and how are we actually going to really make this roll out for everyone.
Thanks, Craig. So, I mean, a couple points. If we're not conscious about teaching and scaling this across Africa, you get increasing inequality, haves and have-nots, and you leave behind a continent, right? Like getting this wrong has huge long-term effects for the world, but huge opportunities if we get it right. Just practically what we're seeing on the ground. So there are massive issues around connectivity and electricity. So those two things across Africa, particularly out of the cities, are huge problems. Like there is no electricity, there is no connectivity. I was in Kenya this week on the coast, and there was like no electricity there for 3 days. So it's a real problem, far worse than what we're experiencing in South Africa, sort of point one. Point two, you know, we've partnered with ALX, and they've got sort of core locations in and outside of cities where students can come to get the connectivity and electricity guaranteed, right? Cool, so that's like hugely helpful. And the third point, which I can't stress enough, and I won't have enough time to explain, is young Africans are incredibly resilient, have huge grit, and want to make something of their lives, right? Like that level of hunger and resilience is very different to what I've seen in the developed world. And it's like what you read in books, right? Like the youngsters will get up at 3 a.m., a 3-hour travel to get to the cafe or to the location to get the connectivity, and like that's what they're willing to do. And that level of drive will be hugely valuable in 5, 10, 20 years time once they've sort of like stepped onto the ladder of employment, right? So, you know, I'm sort of jumping around here, but huge issues. You need to be creative in trying to solve it, and these youngsters will go the extra mile to succeed.
Thanks for sharing that, Shaun. I just fascinating on that last point you just made there. Slightly tangential to this, but I just watched a very interesting show on Eliud Kipchoge, who did the sub 2-hour marathon, and they were trying to understand how someone could ever do that. Physically, he was right, and he had all the things, but it's not enough. And they said the research has actually shown that people who are brought up in difficult, that's why Kenyans are typically so good, in quite difficult situations, had that mental extra thing that enabled them to push their body to these extremes, you know, which in a way is heralds wonderfully for maybe what is the potential in Africa. You know, we have the struggle, but maybe it's also conditioning the mind to actually, you know, go much further.
And just to add to that, Craig, and again, could go on to this for a long time. So the big success story in America over the last 50 years has been the Eastern European immigrants who have come there and sort of built the unicorns, right? So that story has like an example, a lot of like Israelis too. Again, a practical use case, and I'm hopefully not offending anybody, but a youngster in Africa who's got nothing, they will go to the ends of the earth to earn $1,000 a month. PhD, hardworking, 12 hours a day, right? In the UK, somebody's been brought up quite wealthy, you know, they're not going to get out of bed for less than £5,000 a month, right? So it's just a different level of like position and hunger and work ethic, which is a huge asset, right? Like that is a great starting point and will propel us to succeed as a continent.
Yeah, thanks. And Shaun, I think this is what you're saying is, and what Craig you picked up on is just expatriate populations always thrive because they have the fortitude to pick up roots and move and but anyway, that's a different discussion. But Bruce, your comment on the issue of ethics. I mean, this is a big issue, and you know we're not going to deal with the details here, but certainly it's on the tip of everybody's tongue. You know, and everybody's talking about ethics of AI. What's your view on that, really?
Indeed, yeah. In fact, it's such a deep and rather extremely broad field that you know, it's heavily populated with people from philosophers to computer scientists that have decided to pick this up as well. What's reassuring is that, you know, all the way from UNESCO down to much smaller organizations, there's a lot of work that's been done, and South Africa and Africa in general have actually been significant players in this. In helping devise the frameworks for ethical and responsible AI. There's also a significant amount of work going into, for example, technical approaches to designing ethical by construction systems. And, you know, these are very, very difficult nuts to crack. So there's no doubt that this will take some time before we actually have that realized. But it's this multi-pronged approach of solving some of the technical issues, also relating to things that are seemingly tangential but tie into this of privacy by construction, and of course all of the security issues as well. And then also the the other things that are sometimes viewed as being a little bit more checklisting approaches, but still are tremendously valuable of having these frameworks. Now, of course, getting these things written into law, that's a little bit more tedious. I think we can in the near future more easily rely on organizations picking this up for themselves, either because it's the right thing to do, or because of to a small extent a little bit of fear that not doing the right thing is going to lead to organizations being caught with their pants down. So I think that that is not a bad thing, that there's a bit of fear at play as well.
But Bruce, while AI development remains in the hands of responsible corporates, Google and Microsoft and OpenAI, etc., we can expect that there might be some guardrails built in. But if it's, we read recently that Lambda AI is in the wild, right? It's been released, the entire source code, which means unethical people can start developing it and release it. So we certainly have no control over that, over that development. So it seems to me that the ethical side of it, of course, then comes to the end user, rather than relying on the manufacturer or the creator, if you will, to embed it.
Indeed. No, I think you actually hit the nail on the head there with something very interesting, Manoj. It's simply not doable for government, for example, to take on the burden. It's under-resourced, regardless of which government we talk about, but under-resourced to actually fully police that from a technical perspective, but also from a policing perspective. And I think we're going to see the same thing, or at least a parallel of what happens in cybersecurity, where we need to get to the end users and up the level of education in recognizing what the issues are, whether it's misinformation and disinformation and other manipulative aspects of AI combined with social media, or recognizing when there's something nonsensical occurring within AI. So and we've all seen these hallucination examples, but of course those are a little bit funny. But now we move on to ones that are out and out malicious.
Yeah, thanks, Bruce. Tell me, is Jonathan still here?
Yeah, I see he's still there. I think just get a question to him before he flies off.
Yeah, Jonathan, there's lots of chat about the issue of the universities, and I think the comment, and Craig raises, you raised as well, just to elaborate on this. So what can we do about management being on a 5 years? You see, I think my view, it's my personal view, is that academics are in there for the lifetime. Bruce, Craig and I have been working for the same institution for more than 30 years. But administrators are there for
looking at us. You would just make that point.
Yeah, but administrators are there for a 5-year cycle. So their horizons are different, and their focus is different. So how do we deal with this? It seems to be an impossible thing to sort out.
No, it isn't. You and I both served, and I have wonderful memories of that. Both served in the the senior academic community of our university, on the Senate of the university, and nothing stops professors from bringing onto the agenda of a Senate or a Senex, the executive of the Senate, and sort of saying, we want some serious discussions on that. A university leadership, and I was a vice chancellor once, you can't ignore your senior professors bringing to the campus, or in this community here today, important people from around the world, making it an issue. You can't ignore it if you don't make it an issue. So I think we underestimate the power of senates, for example, or senior professors in or out of the Senate, to bring these issues to the table and insist that the university makes the university leadership makes, first of all, the investment in resources in order for these kinds of discussions to happen, but also to make appointments, of people who are at the top of their game, and bring them in either as associate or adjunct professors from the business world, from the IT industry, etc., to teach our students in both, etc. I'm very happy to see, for example, some universities, including my current university, having some serious people that have decided in big data, both in public health, but also in computer science. But that energy can and has to come from the bottom, because when you're as I'm just looking at the troubles university leaders are having, and I remember a phrase I learned in the US once, when you're up to your ass in alligators, it's hard to remember the original goal was to drain the swamp. And I think a lot of our leaders, are in that situation at the moment where the academic project has to come from elsewhere. And I think that, and in fact, Manoj, I think that's what you and Craig and others are doing today. And insist and persist and bring it to the attention of your senior leaders, particularly your DVC academic or whatever they call them at each of our universities.
Actually, just to follow on that, Jonathan, I put you on the spot here, but what do you think is going to happen if you're trying to look into the future in the next 5 years if universities don't respond as they have not responded to many of the other technological advances? They don't respond to this AI challenge and say it's business as usual. What do you think is going to potentially happen?
Oh, there will be an enormous impact. And let me just take a very simple example. There was only about 5 or 6 universities who were able to make the seamless transition I mentioned earlier from face-to-face to online. Very few universities. The rest lost major learning time, teaching and learning time, and that you can't recover in the few months that a university has available. Secondly, I sit on the board of 1 or 2 big funders. They're not prepared to put money right now into universities building the basic infrastructure for what we're talking about. They look to where there's already action, where there's already momentum. So you lose out on investment opportunities, number one. And number two, when the next crisis hits and people like, the Karim, Slim and others tell me there will be another crisis, of pandemic proportions, half our universities will be played offside.
Craig, can I maybe follow that on and maybe hopefully say something not too controversial?
Go for it.
So firstly, I lectured at the University of Natal. I'm an academic. I love universities and they have a huge place in the world, but there's definitely scope for them to evolve and iterate. And maybe sort of how we look at the world, right? So my understanding is that a university degree costs, 40,000 Rand, but a lot of that is subsidized from the government. So the true cost to the state of a degree is call it 150,000 Rand times 4, which is 600,000 Rand for 4-year degree. And the percentages of those students that get employed, call it 50%, and it's lower than that. So you're spending 1.2 million Rand per job, okay? Because employment's actually what matters here, right? For 90% of the students. So 1.2 million Rand per job, and somebody can do the numbers and get it right. I think it's more than that. You scale that across millions of South Africans, that's billions of dollars that we don't have, right? These sort of new models that are agile, cheap, learn to earn, in our world, it costs $500 to take somebody from a trick to get a job earning $24,000. The economics and the practicalities and the budgets, it's just not sustainable to continue to spend at that level, right? There's a new agile, cost-effective, online blended way. There's just no other way to get this right at scale on the continent. Maybe controversial, but that's certainly how we think. And I think, new models are and will evolve over the next while.
Shaun, just to pick up on that, I think what is interesting from my perspective is universities have changed. Originally, universities were institutions of research. You typically were studying philosophy. We've become much more, to use the South African terminologies, technicons, trying to churn out skills. And, maybe in some ways, for various reasons, we've done that. So you wonder whether a lot of that's going to be moving out and going other places, and universities potentially are going to go through a cycle, going back to their roots again and becoming research places, academic institutions, and not those more technicon type based institutions. And a lot of that may then, as we've already seen, we've got these big edX organizations, etc., providing these skills online in bulk. So maybe we are starting to see a big change that's going to happen from the private sector also pushing in. Sorry, Governor Hodge.
Yeah, Craig, we have a question. We have a hand up in the audience. Perhaps you can give Janet a chance to ask her question.
Okay, I just wanted to say that I feel a little bit more positively about it. I think UKZN has actually been quite proactive in this regard. I've attended some remarkable workshops by UKZN on the subject. And I've actually been leading a kind of a drive in the School of Accounts, Economics and Finance, where we look at the implications of AI on assessment, research, teaching and learning. And the more the panel of us doing research into this, and the more we've kind of investigated, kind of the less threatened I feel by AI, but I think that what's vital is that you talk to your student body about it. So I think that having a honest conversation with them, because they all know about it, and to point out that it can hallucinate, references, etc. However, I think we need to realize that it is a powerful tool for also for second language English speakers. People have said to me that it has been incredible how it has helped them articulate some of their thought processes. It's a starting point, but they need to be aware of all the fact that it can hallucinate facts, so it requires checking of all the facts, that you need to make sure that you put it in your own words, you make sure that they're aware of some of the tools that are out there. Although, as I say, we've investigated many of the detection tools ourselves, and at this point none of them are up to scratch. We've used our own journal articles to test this. I've also attended some workshops around publication and research, how this AI affects this, and most of it is really, really positive. It's amazing how it can reduce the time to find amazing articles and kind of summarizing key facts. And so and you can argue, well, we used to have to spend 100 hours looking for that, but it's just where to go, where in the literature, and we've kind of all in our particular areas have looked at some of those tools. We have a series of workshops where we investigate them, interrogate them in our areas that we're more familiar with, to see whether it's providing like a concise summary of that literature. Obviously, you then got to go and read it, but it highlights. It really can help students enormously with their research. So I feel a lot more positively about it, but I believe you've got to have a policy. I've asked our dean for a policy that is given to students before any assessment is handed in, where they are aware of the implications of just using it, etc., etc. And so, yes, the nature of assessment does have to change. You can no longer get, I see there are people from schools attending this, and you can no longer just give students a PowerPoint presentation, because Tome can produce it for you remarkably in a matter of seconds. But so the nature of assessment is forever more change, which is why we cannot ignore it. But I think that there's a lot of amazing, incredible things about this. And I feel quite positive the more that I have researched it. So that's just what I wanted to say. And I salute UKZN in this regard for being so proactive. And there are some incredible workshops that people want to watch those recordings. Thank you.
Thanks, Janet. Well, that's really, yeah, absolutely. I must say that's why probably Manoj and I, be very positive about the changes this can bring. But it's absolutely what you said, and I think Sue McKenna is going to speak in our next part shortly. Talked about us, the whole plagiarism side. We have to educate our students. We can't bluff it doesn't exist. We need to change our game, up our game, as Jonathan was saying, and we can't see this as an arms race. Can my AI out AI your AI? That's not going to happen. We've got to actually relook at how we're doing our teaching and learning. And I think it might have been mentioned in the chat, or it might have been, I can't remember which session I've always been in, but where someone was talking about the fact that when it comes to using AI in our class, in our courses, we need to understand that we actually need an AI literacy. We talk about digital literacy. We actually going to need to move to having AI literacy, and that's for students and for academics and teachers as well. Right, Manoj, do you want to pick up any final questions before we jump into our next part?
No, I think we're okay, Craig. What we will do, I think, is we will collate questions that we've missed from the chat, and we will put it to our panelists, and for brief answers, I will post it onto our website. So at least we'll get some feedback there. But yeah, I think we can move on, Craig, with the next session.
Thank you. Right, so what we're going to do, we've just moved things around. We're just going to have well, it's not really a break. We'd like you to watch it. We've created a short little video, and by someone by the name, as you can see, Lara Tunning. And Lara's not with us. I'll share Lara's video. But before I play it, I'm going to ask, Manoj is going to give you a little bit of a background to Lara and to what Lara is going to be speaking on, which is under the topic of AI research in 2022, a summary and implications for higher education.
Yeah, I think so. So what I did was I searched the web and I said, give me the top research papers in AI from 2022, and somebody else had curated this, and I went to this. There were 30 papers there. Now, to read 30 papers in any length of time, as all academics would know, is very difficult tasks. But what I normally do with research, even before AI and before chat, is I'd read the abstract, the introduction, and conclusion to determine whether the papers are of interest to me. So I did it with all of these papers, and what I did was I cut and pasted each of them into ChatGPT and asked for a summary. So Chat provided a summary, and while I was doing that, I also went. The site had a very nice link to YouTube videos that explained the paper, each of these papers. So I went through them. So I had to have an understanding of what the paper spoke about, which means I could understand the summary that Chat was making, because it's very important to understand. There are even students amongst us, if you ask Chat for something, it gives it to you. And as people have pointed out here, it's not necessarily true. You have to know what you're talking about to understand what Chat is saying. It provides a good summarizing tool, but you need to understand whether the summary is valid or not. So anyway, that's what I did. I put it all together. I created a summary, and then I asked Chat to create a narrative or the thread going through each of these short summaries. And I generated, I think, a paper of page or two, just a summary. And we said, okay, what are we going to do with this? We said, let's let Lara Tunning, speak about this. And Craig will speak a little bit about how he created Lara Tunning. Thank you.
So thanks, Manoj. So basically, using GPT-4 as an AI tool, the script for this that you're going to see has come from that. So this is basically a blend of obviously Manoj guiding it, which I think is going to be a key theme, and we've seen that come out over the human guides this tool, and that's what it is, a tool. But the AI obviously as a tool can produce all sorts of interesting things. So having looked at all the paper, the AI then came up with a script for this short presentation we're going to share. But obviously we wanted to push it a little further. So we then created an image, generated an image using Mid-Journey of someone who we decided could be Lara Tunning, putting in whatever specs we wanted. Then we created a voice using an app called 11 Labs for Lara. We then used video animation using DID. And then the slides also, as was mentioned, that you can do, we used a thing called slidesai.io and also Bing Create for some of the images. So literally everything in terms of the visuals that are here, the text, the speaking is actually AI created and under the guidance of myself and Manoj and one or two others who are just helping direct it. So I'm just going to share this short video with you.
Hello, everyone. My name is Lara Tunning, and I'm excited to be here with you today. But before we dive into the world of AI in higher education and research, I have to ask, did anyone figure out what my name is an anagram of? It's Alan Turing. That's right, the famous mathematician and computer scientist. I like to think that my name is a nod to his pioneering work in the field of AI. Now I know what you're thinking. Lara, if you're so smart, why do you look like a computer-generated avatar? Well, I like to think of myself as a digital native, born and raised in the world of technology. Plus, it's a lot easier to update my software than it is to go to the gym. But seriously, folks, today we're going to explore the latest research on language and image AI tools in higher education and research, and I'm excited to share what we've learned. Let's get started, shall we? We reviewed 29 key papers in AI published in 2022 that encompass a wide range of topics, showcasing advancements and innovations in artificial intelligence, computer vision, and natural language processing. These studies push the boundaries of what is possible in these fields and pave the way for further breakthroughs in AI and computer vision. A key theme in these papers is the development of techniques to generate and manipulate images and videos using natural language. One such method, Make a Scene, offers scene controllability for improved human perception and quality in text-to-image generation. Similarly, Dream Fusion enables text-to-3D synthesis using pre-trained 2D image text diffusion models without requiring 3D training data. These advancements demonstrate the potential of AI and computer vision technologies in various applications, such as art, entertainment, and storytelling. Another recurring theme is the improvement of learning and adaptation in AI models. For example, the panoptic scene graph generation task generates comprehensive scene graphs based on panoptic segmentations instead of bounding boxes, leading to better scene understanding in images. Additionally, the paper on expanding language image pre-trained models for general video recognition presents an approach that adapts pre-trained language image models to video recognition tasks, showcasing the versatility of these models in different domains. The development of large language models for specific applications is also a notable area of research. Galactica, a large language model for science, addresses the problem of information overload in scientific research and has the potential to revolutionize how scientists access and interact with scientific knowledge. This demonstrates the power of AI in tackling complex challenges across a variety of fields and suggests parallel developments in the law, medicine, and other fields. In the realm of software development, AlphaCode and Codeformer are two significant advancements. AlphaCode generates code from natural language descriptions using a pre-trained language model, while Codeformer translates between programming languages using transformers. Both of these methods have the potential to streamline and simplify the development process. The research also highlights advances in 3D modeling and animation. Banmo creates animatable 3D models from casual RGB videos without the need for specialized sensors or pre-built models, demonstrating the potential of AI in the field of computer graphics and animation. In a similar vein, the paper on real-time neural radiance talking portrait synthesis presents an efficient framework for generating talking portraits using neural radiance fields, showcasing the potential of AI in the entertainment and advertising industries. Finally, the studies underline the importance of considering the societal impact of AI technologies. For instance, EDIF-I, a state-of-the-art text-to-image diffusion model, raises concerns about potential malicious uses and the creation of deceptive content. As AI continues to advance and integrate into various aspects of our lives, it becomes increasingly important to address the ethical and societal implications of these technologies. In conclusion, the research papers summarized here offer a glimpse into the exciting advancements and innovations taking place in the fields of artificial intelligence, computer vision, and natural language processing. These studies not only push the boundaries of what is possible in these areas, but also pave the way for future breakthroughs and applications, impacting fields as diverse as software development, art, entertainment, robotics, and scientific research. These developments will significantly influence higher education institutions in various ways. As AI technologies evolve, curricula need to be updated and adapted to incorporate the latest techniques and concepts, ensuring students acquire relevant knowledge and skills. These advancements will also create new research opportunities, enabling institutions to collaborate on innovative projects that contribute to knowledge in the field. AI-driven tools, such as large language models, can enhance teaching and learning experiences by helping students access information efficiently and facilitating personalized learning. Advancements in AI and related fields will also enable the development of immersive virtual learning environments, making education more accessible and inclusive. Simultaneously, AI can streamline administrative tasks, allowing institutions to operate more efficiently. As AI becomes increasingly integrated into higher education, it is crucial to address the ethical and societal implications of these technologies. Institutions must develop guidelines for responsible AI use and incorporate discussions on ethics and societal impact into their curricula. By adapting to these changes and leveraging AI technologies, higher education institutions can enhance the overall educational experience and stay competitive in a technology-driven world. Thank you for joining me today in exploring the exciting advancements and innovations taking place in AI. I hope this discussion has inspired you to consider the possibilities and potential of AI in your own work and education.
Right. Thank you, Lara. That was interesting. As I said, everything there was basically generated by AI, including her script, her little jokes, and everything else that was.
Sorry, Craig, perhaps I could come in here. There have been some comments, I think, in the chat about, you know, two males generating a female avatar and named after Lara Croft. Lara Croft is of course, the name was selected by chat. We asked chat for anagrams of Alan Turing, and it came up with that. So yeah, clearly, but I want you to rather think about the possibility of using generated images like this, or even, you know, so for example, having a child learn from their famous cartoon character, you know, learn mathematics or science or physics or whatever the case may be. So there's a huge potential here. Of course, there are copyright issues and there are image rights issues and things, but the principle is you can create an avatar to teach a child, you know, whatever it is. And we all know, who have had children, that, you know, it's much better to teach face to face or have somebody talking to the child than to have, you know, them try and read something. So there's opportunities here. And yes, the ethical issues will always be there. If we had chosen a male, then we would have a problem of having all male, except for Sioux. You know, there was a comment made in the chat as well. There's all males over here, but it's just a function of the people we know, I think, in terms of the research going on at the moment in this colloquium. But clearly, I mean, these are issues that need to be dealt with in the wider environment, not just in AI. Yeah, Craig, I think we can move on now. Yeah.
Right. Okay. So thanks to Lara for stopping out and sharing that information. And I think maybe what is interesting is how these tools can be used to actually help us get an understanding of research. You know, and again, they are tools, and they can help us get summaries of things and help us speed up our processes. Right, we're going to move on to our next two panelists, because we've moved. Jonathan came up earlier and did his session, and next up we are going to have Professor Sue McKenna speak to us, and she's the director of the Center for Postgraduate Studies at Rhodes University and visiting research professor in the Center of International Higher Education in Boston College in the USA. And she's going to be speaking to us on enjoying a transformative relationship to knowledge in the age of AI. We actually read some of her stuff that she had posted, and I think it got into the conversation in other places, which is really interesting. And so we're looking forward to Sue, if you want to take it away.
All right, great. Thanks, everybody. Well, obviously, the relationship between higher education and artificial intelligence is an extremely complex one. It's evolving every minute. In fact, it'll be evolving in the next 10 minutes while I'm talking to you. So I can't possibly talk about all the things I'd love to talk about, including some of the very interesting conversations that are happening in the chat bar right now. A couple of the things that I would have loved to have chatted about is the extent to which universities are nurturing critical literacies, because we need them now more than ever in an era of fake news, misinformation, and potential AI hallucination. I'm also passionate about the extent to which universities as public good institutions are actually leading or actively participating in deliberations about the social and environmental consequences of artificial intelligence. But to keep to my allotted time, I'm going to restrict myself to discussing just one issue, and that is the argument that pertains to the purpose of higher education. And in particular, I'm going to be looking at the implications of AI for the undergraduate curriculum. For many people, higher education is about credentialing someone for employment. You pay your fees, or you make sure your fees get paid for you. You attend your classes, you submit your assignments, you write your exams, and when you've successfully completed all of the requisite tasks, then we give you the piece of paper that indicates as much. Given the enormous economic inequalities in our society, I think it's very logical that for many of our students, this is the dominant understanding of what a higher education is all about. A university qualification holds the promise of meaningful employment that could potentially lift the student and even their whole family out of poverty. But this instrumentalist understanding of a higher education as being related entirely to the economic benefits brings enormous negative consequences for how we do things within the university. And in this understanding of higher education, artificial intelligence can topple the entire house of cards. If artificial intelligence can more speedily and efficiently complete all the tasks that we set for students, and if the role of the university is simply to verify the completion of these tasks, well, then the entire currency of the university qualification collapses. So I think it's hardly surprising that many universities are responding to ChatGPT as an existential threat and are rushing to purchase AI programs that can identify when students have used AI programs. As with the police catch punish approach that universities have used for many years, decades, in regards to plagiarism, we will no doubt see dire threats of exclusion for students who use artificial intelligence to complete their work. And then if the AI surveillance software indicates that the student might have used AI software in their own work, then the students will be made to pay the price for this misdeed. This is the playbook that's already in place in our universities, and which universities are now ratcheting up to address the rise of large language modeling. It just tells me that my battery's about to die. Because if a university is selling a product, then AI offers a knockoff version that is quicker and cheaper, well, then the product that we're selling very rapidly loses its value. But, of course, these instrumentalist explanations are not the purpose of a higher education. A higher education is not a product. Knowledge is not a commodity. And while universities serve a great many purposes, and credentialing people for the workplace is a subsidiary and minor aspect of what we are or should be all about. Because when economic drivers of higher education dominate, then the educational ones will always, without exception, be sidelined. So then, what is a university education for? Well, a great many philosophers and researchers have tackled this question before me, but the definition that pleases me most for its succinctness and its expansive meaning is Paul Ashwin's look at what an undergraduate qualification is for, and he says as follows: a higher education entails students being transformed by the knowledge they are studying and thereby changing their understanding of themselves and their place in the world. This is about so much more than the completion of a series of tasks or the development of generic skills or the gaining of information, though it might include all of these things. As my colleague Mags Blackie indicates, for example, to enjoy a transformative knowledge relationship with chemistry, to become an expert knower in chemistry, if you like, is to be able to understand the world at a molecular level. And I think there's something very beautiful in that definition. Or to draw another example again from Paul Ashwin, he describes becoming a sociologist, and he suggests that a lot of students study sociology simply because they're interested in contemporary social issues. But as they begin to enjoy this transformative relationship, they can even have a sense of loss as they realize that they are integral to and even benefit from the social systems that they are learning how to critique. So the point is that in all cases, a higher education is about transformation as students take on the powerful knowledge of the fields. And to quote Spider-Man, with great power comes great responsibility. So as students are transformed in how they come to understand the fields that they're studying, understand aspects of the world, so they also come to take on the responsibilities of critical citizenship. This is not to suggest that universities should disregard the future employment of their graduates or neglect to connect the powerful knowledge of the academy with the powerful knowledge available in other social spaces. Rather, it is to argue that we need to place the educational purposes of a higher education front and foremost in every conversation we have with each other as academics and with our students. At this point, some of you are probably thinking that I've forgotten that this is a colloquium about artificial intelligence. So let me return to that. If the undergraduate curriculum is, first and foremost, about nurturing a transformative relationship with knowledge and one's sense of being in the world, where might artificial intelligence fit in? In this understanding of higher education, AI now becomes a potential tool to be used to foster such transformative relationships. And we would, of course, also need to ask questions about how AI might constrain or corrupt such transformative relationships. And we need to engage our students explicitly in conversations about such enablements and constraints. Certainly, AI requires that we rethink both the form and the function of assessment. If we are educating students towards a transformative relationship with a body of knowledge, what assessments will nourish that? We'll need to reflect deeply on why we are assessing, and Jonathan referred to this earlier. And if AI can easily perform the task that we're asking students to do, then we need to reflect on whether students should indeed bother learning about how to perform the task for themselves at all. Don't get me wrong. I think that there will be cases where we still want to equip students to perform tasks that AI can already do for them. Perhaps, for example, we might want chemists to understand by heart the nature and meaning of the periodic table, or we might want sociologists to be able to draw on multiple texts to establish their own position. And if so, well, then we need to equip students and assess them on these. But with this understanding, we shift from the question of how will we catch students using artificial intelligence so that we can punish them, to asking how does this assessment build students' relationship to knowledge, and how might artificial intelligence enable or constrain this? As it stands, the dominant account of higher education as the transfer of a commodity from a service provider to a customer is completely doomed by AI. And quite frankly, good riddance. But thinking about the purpose of higher education as transformative will entail a lot of winning over of hearts and minds of both our students and our colleagues, because there is so much investment in the narrow technicist account of higher education in our universities and in how the public discusses the purpose of a higher education. So it's not going to go down without a fight, albeit an entirely time and resource wasting fight. And so in the next few years, we will no doubt see more and more surveillance of our students, and we'll see many universities taking quite a while before they actually start engaging with what a university curriculum focused on enabling a transformative relationship to knowledge in the era of AI actually looks like. But thankfully, in every university, there are already pockets of passionate people who are engaged with such attempts. You're going to find in every university academics who already debate with their students what a university education is for. These academics ignite in their students a desire for access to powerful knowledge that way outstrips the value of any piece of paper that we can provide to them. And these academics are asking how best to respond to AI, using an approach that helps to build trust, belonging, and transformative relationships, rather than mistrust and suspicion. Thank you.
Thank you so much, Sue. It's fascinating, and it just resonated so powerfully with everything that we've heard from all the other speakers. And I think even it's come out in the conversation that that there is change, but there are people in these institutions, even in school institutions and higher education, who have always thought how you are saying, how you're defining what education is about, what higher education is about. It's a transformative space. It's a space of, as Jonathan was pointing out, it's not just a space where we try and do these summative tests to see if you've got past, some things that we put in there. And AI has so many opportunities. And as you said, maybe it'll take a bit of time. and how the model spins out and how universities change in response to that, we're going to see. But there's definitely, just by the virtue of the people that are here, there's lots of passion to take this new and very exciting and scary tool and let's do something with it. And I think, as you said, Sue, that it's probably one of the biggest tools that gives us the opportunity to rethink education, because all of a sudden the things we always did are out of the window. So that was absolutely fascinating. So thank you very much for sharing your thoughts. We're just going to go across to our last presenter, and then we will just have a brief time to have some open discussion once more before we conclude. So I'm going to now introduce our final presenter for today, and that is Bilal Kathrada. He is an entrepreneur, and he's also the founder and CEO of IT Varsity, among besides some other companies as well. And he's got an interesting topic: how AI will take education back 2 centuries. So that's very interesting. So over to you, Bilal. You just need to unmute as well, please.
Thank you, Craig. Well, I must say it's been a very exciting program, and I'm glad that I'm coming on last, because I've absorbed all of the information that was coming across from the brilliant speakers, and sort of reflecting on that in my talk. Can you hear me?
Yep, you can.
Yeah. Can you see my screen?
Yes, perfect.
Okay, perfect. Yeah, so thanks for the opportunity to speak here and to share some of my thoughts, and to basically, more importantly, to learn from the brilliant panel of speakers. Okay, so as you described, I'm the founder of IT Varsity, but I also run a number of other companies like Clink, Zende Educational Apps, and CompuKids. Now, one of the things that prompted me to start IT Varsity, to found IT Varsity, was to find a different way of learning, a type of learning that actually goes way back to when universities were not accessible to the most better part of the population. When you needed to learn a skill, you would typically go to a master, somebody who is experienced in that skill, and you would be an apprentice to that person until such a time that you yourself became a master in that. So basically, you would spend years and years and years studying under a master, and then you would become a master yourself. So I started IT Varsity more as an experiment than anything else. So the idea was to take people who have graduated from universities with this body of knowledge, of theoretical knowledge, particularly in the computer science space, and to accelerate them into software engineers, into coders, into careers in the software engineering space. And while the business was small, I mean, I started this little classroom in my backyard where I had maximum 10 people. Things were going great. But then the one day I actually encountered a bit of a problem as my classes started to grow, right? So I would teach the concepts, as you guys are very familiar with, and I would ask my students to go and complete assignments. For example, I would teach a concept in Java and then get the students to go and write a bit of code for me or build a little application to complete certain tasks. But I noticed that time after time after time, the work wasn't being done. And this was a bit frustrating for me. And so one day I decided to interview the learners, and I asked one particular learner, what is going on? You guys seem to understand the concepts in class, but why don't you complete my assignments that I give you? And so the one learner put it very nicely, and actually he shaped the way that I think about education since then. And he said, you know, sir, the time when I need you the most, you are not there. So I thought about this and asked him, what do you mean? He says, look, understanding the concepts, that's the easy part. I understand that. You don't even have to explain it to me twice. I get the concepts. But it's a time when I'm doing these exercises that I struggle the most. And I wish that you were there, but I'm at home and you are somewhere else. And it's not possible to ask you the questions. And you know, with a subject like Java, which is highly practical, which is with coding in general, where one little dot out of place could crash your entire program, it can become very frustrating for learners. So what I did was I actually inverted the whole learning routine. So basically, I made videos of my lessons and got the learners to study those lessons at home. So they learned the concepts at home. The next day in class, they came with the concepts all buzzing in their heads. And then I would get them to do tasks, programming tasks. And I would look over their shoulders and I would help them to debug their code, help them to complete those assignments. Obviously, they would do everything themselves, but I would assist where they needed help. So fast forward to, say, around 2020, 2021, when my classes went from 10 and 12, just 7 or 8 years ago, to 10,000. And now we're sitting with a different problem. And that problem is, how do I look over the shoulders of 10,000 students? I mean, currently at IT Varsity, if I'm not mistaken, there's about 20,000 students enrolled for our software engineering courses. So how do we do this? How do we fix this? How do I become a mentor to so many people? Clearly impossible. And that's when the conversation around AI came in, and the revelation last November when ChatGPT, generative AI, came into the picture. And that was a major revelation because now, for the first time, there was the possibility to actually create clones of myself as the lecturer, as the mentor to all of these students using AI. And so that's what we are doing. We're using AI to create essentially a clone of me or any lecturer that lectures at IT Varsity, so that the learners can get almost personalized mentorship, almost personalized guidance through these through this AI, which basically mimics what the lecturer was supposed to do in terms of supporting the students. So Caitlin actually stands for Kylix, which is the actual name of the company that owns IT Varsity. Kylix AI tool for learning enhancement. It's actually a very, very comprehensive tool. So what does Caitlin do? Caitlin can or will be able to, it's already in active development, parts of it are already developed, but it will use a generative AI to support learners at any time that they need support, whether they are working during the day or the middle of the night. So they would be able to ask questions, even put in snippets of code and get some hints on how to fix that code. Caitlin will also, more importantly, do learning data analytics. Now we are generating tons and tons of data, not only as IT Varsity, but even in my app business, Xander Educational Apps, for example. We just did a major rollout in the Western Cape in partnership with the Western Cape Education Department of our apps. Apps for kids from early childhood development through primary school phase. We rolled out to 200 schools. So in effect, we are going to be working with close on to 50, 60,000 children. But I'm a stickler when it comes to data. I want to know everything about what these learners are doing. Are they using our apps? How are they using them? Where are they succeeding? Where are they struggling? I want all kinds of information, and we are collecting that data. But now, where does that data go for analytics, or providing insights? That's where Caitlin comes in again. So Caitlin will be offering us very, very complex and very, very important data that we will be able to give to the Western Cape Education Department. And as we expand throughout South Africa, both with the Xander educational apps and CompuKids. CompuKids is our brand to do coding and robotics classes with kids. We want to be able to provide data on every single child, every single area, every single city and town and rural area, how the learners are doing and what they are doing. Caitlin also will do monitoring and evaluation. And the reason for this is very practical, because Caitlin will be able to determine which learners are struggling, which learners are at risk, and then offer them preemptive support. So it will say something like, hey, Tom, I see you've been working very fast, but when you came to this section, you seem to have slowed down. How can I help you? And Caitlin will be your friend in that sense. And in that way, it will do learning diagnostics, and it'll provide feedback both to the learner and to us. So we will be able to detect in our curriculum bottlenecks where learners are finding difficulty on certain concepts. And so we would be able to go in and sort of revamp those sections or offer more support in those sections, in the more challenging, more difficult sections. And the learners will be given customized learning paths. So that's one of the biggest problems in cumulative subjects like mathematics and coding, right? If you missed a concept somewhere along the line, then down the line, that's going to come back and haunt you. So Caitlin will detect that, and it will say to the learner, perhaps you've missed out something in the section under for loops in Java. Why don't you go back to lesson so-and-so and work through that and come back here, and that will assist you in understanding this. Now, it's all very complex, right? But thanks to the slew of AI and the advancements of AI, these are now well within our reach. And as I said, Caitlin is already in active development, and we are now speaking to a number of companies next month onwards on a round of funding. I mean, up until now, IT Varsity has grown considerably, and we've worked with some of the biggest companies, as you guys probably saw in the previous slide. But this was all with zero funding. This was all bootstrapped, as they call it in the startup ecosystem. But to go to something as complex as Caitlin, we are going to need help, and we're going to bring in some of the best AI experts in the country to help us develop this tool to a point where it can be applied not just by IT Varsity, but by any learning institute, and not just when it comes to IT subjects like coding and software engineering, but pretty much any faculty, any subject. And that's on the roadmap, and that's what I call IT Varsity version 3.0. So that's it. I know my presentation was a bit short, but I think that gives a lot more time for questions and answers. And yeah, once again, thanks for this opportunity, Craig and Professors Craig and Manoj. I really appreciate it. And yeah, I will conclude with that. Thank you so much.
Right. Thanks very much, Bilal. Again, lots of interesting things being done there, and there's a lot of work in and thought around AI in education, being able to personalize learning. It's a phrase you often hear. And that's what a lot of this is going to be coming down to, that, in the past, it'd be a standard learning path for every student. We use at UKZ and Moodle, for example, everyone works through topic 1, 2, 3, 4, lesson 1, 2 in the same sequence. Yet not everyone necessarily needs that exact sequence. And I think understanding the learners, where they're at, what they're struggling with, maybe somewhat better, this AI being able to be a layer on top of all of that offers very interesting and exciting opportunities. But I think, as we've seen from Bilal's work and from Shaun's work in ExploreAI, a lot of the private institutions are pushing very fast into this area, and it's going to be something that as primary and secondary and tertiary education institutions are going to need to start to look at. Right, so that is everything from all the presentations. We want to have an opportunity just to have some final conversation with our panelists. I know some had to, we lost this one, get Bilal back. Yeah, so we lost a couple who had to go off and fly and go to different places. So I see we do have a panelist still here. We've got Bill, John, Sue, Serge, and Bruce. If you can all just pop your cameras on for a second, and we'll just try and conclude with a little bit of a conversation around the various things that we've been picking up on.
Yeah, Craig, maybe I can kick that off while we wait for people to come back on. One of the questions that was asked think there's great interest in the app universe that's been created for ChatGPT. Certainly from my perspective, I'm interested in the Wolfram Alpha app, but other people are interested. So does John have any idea in terms of when we'd have availability of that, Wolfram Alpha in South Africa? Then on the other, and then, similarly, so Sioux, most people agree with what you're saying. So there's not many questions, there are many comments. But I think I can sort of encapsulate some of the comments into a question. Thanks, John, we see you. In terms of, if universities are going to be changed from educational institutions to skills development institutions, I think that's where the nexus of the problem lies, isn't it? As skills development, if we start competing with the IT varsities, and then we're going to fail, because that's not what we designed to do. And I suspect that, and I might be wrong, and we'll have an argument about this, but you can train an AI to be a skills trainer much better than you can train me to be that. But as an educator and as a philosopher of education, I'm probably going to be better than Chat, I hope. But if universities are becoming skills development institutions rather than education institutions, I want you to comment on that a little bit. And Bilal, one of the points made towards the end of the chat here was an important point, and this goes to the ethics of AI generally, is about data, ethical use of data. With AI, you can collect huge amounts of data on everything. And you mentioned about using that data in terms of, fine-tuning your teaching experience. Or the question, of course, is, what about the legalities and the ethics of that, right? So yeah, so I think that's open to all of you. But John, perhaps you first, and thank you for being available. We knew you were busy and you sent us a recording, but here you are. And I think for me as a mathematician, and I think for Bruce as a computer scientist sitting there, we see this Wolfram Alpha link as extremely valuable. I mean, I'm a Mathematica user myself, but when will we see it, and how do we see it evolving?
So in terms of the plugin availability, that's in the OpenAI system now, but they are controlling the rollout, presumably to manage all of their server loads. So there's a waitlist you can join, and I don't know what rate they're rolling out, but I think they're aiming to be at 1 million users with plugins within a month. So if you just search for waitlist OpenAI plugin.
Oh, we've signed up. We're just waiting.
Okay. Yeah. So I don't. We're not in control of that. What we're focused on is actually all of the the wider issue, because OpenAI is only one player. So we've been trying to build out a lot of the infrastructure to make really high-level ways of interacting with LLMs that are not strictly through a web-based chat. Things to call the APIs that allow you to switch the back end to different providers. We're going to be rolling out the first versions of that in the Wolfram language 13.3, which is code freezing in about a week. So that's about 6 or 8 weeks from us rolling that out to end users, and that'll make a lot of this available right now, right then. Although it's changing really fast every day. We're discovering new things we can do with it internally, and there's a debate about can we get those into 13.3 or do they have to wait for 13.4. I also just wanted to comment on something about the kind of embrace of it, because I'm a great believer there's nothing new. We've been here before. And maths, at least from an educational point of view, has been in this state that we're now worrying about all of the other education for at least a decade. That things like Mathematica have made it so that any computation that you spend years learning how to do, like calculus, is instantaneous and better than any human. And while we've been arguing for a computer-based math rethink, ask these questions of, from a maths point of view, what is the maths I now need to know if it's not about being the computer? Because for a long time, the bottleneck was to be the computer. And so knowing all of the processes to integrate and differentiate and solve equations all really mattered. But now they don't. What matters is what do you do with them? How do you interpret them? How do you set the problem up? How do you verify the computer's done the right thing? They're a completely different set of skills. But even when we do this ourselves, and very much when we talk to other people about it, there's this sort of reaction of, that's not the way I learned. I turned out okay, therefore let's not change. And that is really untenable, but it's incredibly frustrating how slow it is to persuade people that maybe learning how to solve equations by hand isn't the be all and end all of algebra. Maybe there are other things that we should learn to do with the algebra, or higher concepts that we can reach. And people give lip service to agreeing and then say, yes, here's how I would do it, and then describe traditional education. And I think we're going to see the same thing go through with these more essay type and argument-based subjects, where people will sort of on the surface acknowledge that the world has changed, but they won't change their behavior. And maybe we need a kind of new generation of educators to work their way through the system, who, you know, the kids these days are quite happy to say, I trust Wolfram Alpha. Now, they probably shouldn't. You know, there is still importance in validation, but they don't need to know how it works. And, you know, we're like that with mechanics. I trust my life to a car system that I have no idea what's going on under the bonnet. I don't know how the brakes work. I'll trust my life to it. Why won't we trust GPT to make a nice sentence out of our argument and focus on things that are left for us, like, is it a good argument?
Yeah, I think the point is, and I've said this, when answers become easily available, it's not the answer that is important, but the questions that are important. You know, you need to know what questions to ask. You know, if you've decided how you want to build a bridge because that's how it should be done, then you can ask somebody to design it for you. I mean, that might be a crude example, but from a philosophical point of view, when answers become easily available, as they are becoming now, I'm not suggesting ChatGPT is the answer machine, but it's going to get that way. Then we need to be able to learn to ask the right questions. And that might be a skill that we're not teaching at the moment, certainly at universities. So, you know, we teach how to find answers rather than ask questions. But, you know, that's...
Someone mentioned in the chat there, Janet, you know, that's why there's this whole field of prompt engineering now. You know, it's shifting the whole game. We need to know how to ask the question to get to the answer, which is something our students have not been trained for, and many of us have not been trained for, which comes back to John's point. We have to be and I've seen that thing over and over again. We turned out okay, and that's how we learned. You know, and it was one thing back in even, you know, I've hit this argument many times, and people at school hit it as well when you try and introduce new. But now it's going to be even more dramatic. You think, well, what do you mean they don't need to know how to do 12 plus, you know, and do the times table? Now that was one now we're saying they don't even need to know how to this formula actually works, you know. But I think it was one of the speakers, I can't remember, sorry, who mentioned a cognitive load. You know, we can only handle so much, but essentially by offloading some of that cognitive load, you actually free up your brain to handle and take on greater tasks, which becomes quite interesting. Yeah, so really interesting that.
I think the challenge there is, can we find those greater tasks that we're now free to pursue?
Exactly.
Or will the negative happen, which is people say, well, now the price of intelligence has fallen, let's pursue something different, like shooting people. So we've got to make sure that, you know, we go higher as a civilization rather than just abdicate.
No, but you're right, John, that's exactly it, because there is the potential that we're seeking the easier. And so these become tools to outsource our brain. And I can even see my own use with ChatGPT. You can be careful that you don't outsource your brain in order so that you create more leisure space for yourself rather than to make yourself more efficient and effective.
Yeah, I think that just to, you know, do as a panel, I mean, we have a few people left, but do we believe that we are, I mean, taking John's point, we're at the cusp. Are we going to go up or down at this juncture? As human beings, let's put it that way. I mean, Bruce, see you smiling. Where do you believe we're going to head?
You're on mute there, Bruce, or something. Or I know you're unmuted, but you're quiet, so you're going to have to go to some sort of text.
Maybe.
Can you hear me now?
Yeah.
Okay. Headsets. Yeah, you know, I mean, my optimist side, you know, really says that I think this is ultimately going to be for the better. You know, it's of course just this massive amount of rejigging things that we've become accustomed to. And really, you know, a lot of the opinion pieces, and I happen to agree with them, you know, point out that this is big. You know, this is invention of the wheel big, or discovery of fission. So we can't look at this as being like little incremental things, not to trivialize electric vehicles, but, by comparison, the move to electric vehicles is nothing compared to what we're facing now. But yeah, on balance, I see it all, looking up. And of course, I agree with, now I can't remember who said it recently, but in the panel here, but I very much agree that we can't just free up all leisure time. There's huge value in just moving up the cognitive chain, and maybe now instead of learning times tables, now we need category theory in primary school, or who knows what else. But
yeah, absolutely. Sue, you had some thoughts on this, because it's definitely right into your domain. We're heading upward.
Yeah, absolutely. And it's very easy not to head upward. I think we must be careful of suggesting that leisure time is somehow going downwards. I totally disagree with that. I think that we don't spend leisure time in ways that feed the soul, and perhaps we should be doing more of that. And that's a little bit of pot calling a kettle black there, but never mind. I think I just want to pick up on something John said, and I think, first of all, Bruce is absolutely right. This isn't an incremental change. This is a massive change, and we need to understand it as such. But, John was talking about sort of mathematical changes, and it made me think of an anecdote of my father, who's an attorney. And, well, he's 86, although he's still a practicing attorney, so go figure. He spoke about the fact that you had to study law. I mean, you had to study Latin when you studied law. Absolutely everybody who studied law studied Latin. And it was only sort of 15 years ago that they said, well, hang on, there's a handful of Latin phrases that all lawyers have to use. They use them all the time, so they know what they mean. And if they come across an unusual one, you've got a Latin dictionary on your bookshelf as it was then, or on your laptop as it is now. And that was considered like mind-blowing, that, oh my goodness, the downfall of standards, we're no longer going to teach Latin in the law degree. And of course, law continued very happily. So I think, John's point is right, that we hold on to things. And the examples I gave, for example, about, do we still need to write an essay? If the computer can do it for you, do we still need it? I do think we just need to be careful here that a university is not for training. Higher education is not for training people. That is one of its facets. It's about educating people. If it were training, the private world is much better equipped to do the training. Industry is much better equipped to do the training. But if it is about educating in those transformative ways I was describing, then we just need to be careful that we don't talk about it in ways that suggest that this is for an elite only. There was no golden era of higher education. I'm not talking about going back to the past. That's not what I'm suggesting. In the past, higher education was about educating the intellectual inner minds of wealthy men. Now, through massification, it's open to all. But at the same time as that massification happened, there's a shift in discourse to understanding the university as an economic endeavor to prepare people for industry. And I think that we've just got to be careful that we're not conflating these two things, because I would like to believe that having spaces to engage at the highest level using artificial intelligence to really think in these higher order ways that really transform for the good should not be restricted only to those who can afford to go to, little liberal arts, fancy elite universities. So there is just a concern that when we conflate the two, it becomes training for the masses and elite education for the few. And I really believe that it's very possible for us to get it right, where we have education that is this transformative relationship, that we have a pedagogy of discomfort, that when you graduate, you should not be the same person as when you came in. You should be forced to confront things and see things in new ways. And it should be in the current world, which means it should be in the world of AI, not in some fictitious world of invigilators walking up and down as you write an exam. I mean, that's just nonsense. It's just totally out of touch with reality. Memorize this, regurgitate it on paper, and we'll give you a piece of paper. That is gone. But I would be loath to see the response to that being that we must now just do training at a higher level. I would hold on to the idea that we can still be integrating AI, and perhaps a lot of it is actually around prompt engineering, getting people to think within multiple fields and in multidisciplinary ways about the kinds of questions that can move us forwards, and how to structure those questions so that we can use AI to its maximum.
I think the Latin example is also a good example of one of the things, self-fulfilling things that education does wrong, which is, I suspect it was there partly as a discrimination. That, at least in the UK, knowing Latin meant you went to a good school, a public school, not a state school, and it's difficult. And so, you've got to pass that test. And maths has been used that way, that algebra is difficult. Therefore, we use it to, if you can do algebra, you're elite. If you can't, you should go and be a plumber or something. And I think we have to start being more broad about what are the skills that, you can be somebody with great ideas who writes a terrible essay, and maybe that's okay, that you can let the GPT express your ideas. We've got to value those things that are not the test. Otherwise, the whole system is about sifting to the top 5% who know the subject so well that they can teach it in the same way to the next generation. And it's totally self-fulfilling, self-aggrandizing.
Yeah, I think, these, Bruce, you mentioned about the wheel. I recall watching an interview recently on YouTube. I think it was with John McCarthy, regarded as the father of AI. And they asked him, how do you see AI today in terms of the history of humankind? He says equivalent to the invention of the wheel. And you mentioned that now. This is really significant. It's an inflection point in our development as humanity, I think. And if we don't recognize it as such, I think then we're going to be in trouble. Serge, you're at the cutting edge of dealing with kind of research in terms of applying AI. In terms of these, your topic today, sustain SDGs and things. What is your experience? I mean, you may not have the answer to this, but because you're working with the United Nations University and perhaps the SDGs and the United Nations, how do organizations like it see AI in the world today? What do they? Is there any cohesive view coming from the UN?
In fact, it's very trendy topics inside UN at the moment. So you heard about the recommendation of UNESCO, but all the UN organization, they are thinking about because basically, and all of you have already mentioned that before, AI is cross-cutting all the whole society, from the education to environmental issues. So so basically all the UN agencies are talking about that and trying to develop some capacities about that. So I'm part of a group of inter-agency working group on AI in UN. So everyone is working on that, UNDP, FAO. So it's very, very trendy at the moment, and this is very important. And for us at UNU, we are mostly interested by research and the impact of these tools. So it's very important also to add the perspective of the global south, because most of these AI systems that have been developed by rich countries, companies, and most of the time the voices of the marginalized population, the developed countries have not been heard until now. So it's very important to take care about that. And this is why we are trying inside our institute to also develop a participatory approach, so how we can involve users in the design of AI tools, AI policies. Trying to hear the voices of everyone involved, because at the end, everyone would be impacted by this kind of tools.
Yeah, I see. I just got a notice on Teams. Apparently, webinars are scheduled for 4 hours or 3 hours, and our time's about up. But we've got time before we shut down. Just the last quick point. I mean, I raised the point about data. The UN is full of data, and ethical use of data as well. So, Bilal, what's your comment on that? Have you talked of collecting data from your students and using them? Is that an ethical issue that you're grappling with, or you didn't think about?
You're on mute, Bilal. Bilal, you're on mute at the moment. Just unmute. There we go. Yeah.
Sorry. It's definitely something we're grappling about. I mean, there are so many moving parts here, but we have a very dynamic legal team that's looking at what is acceptable, what isn't on a global scale, and updating us with the latest. And in the meantime, we are erring on the side of caution, where this data, I mean, without a doubt, if you are using Moodle at your institute, you are collecting tons of data, as an example. Basically, Caitlin is simply taking that data and shaping it and sort of using it for predictive analysis and for improving service to our students. It's the same with our apps that we put out. Anything sensitive, we'd stay very far away from. And also, who needs to see the data will see the data. So be very careful about that. But there's so many, so much of progress that's been made, so many discussions around the ethical issues that we just adopting a wait and see attitude.
Yeah, and I think, just to close off, one of the dangers I see, and just like with all technological interventions in the past, and I think all of you will have similar experiences, is that rather than bringing society together, it divides it even further. So those that have access thrive, and those that don't, regress. And we see that with the internet. We saw that with mobile. We see that with mobile phones. Although mobile phones have become ubiquitous now, so that effect is being smoothed out a little bit. But with access to the internet, I mean, if you have access to the internet, you can thrive. You can learn. You can you can do all kinds of things. But if you don't, you're left behind. And we have the danger that AI, because it's internet based in a sense, you have to have access to the network to be able to utilize it. If you have access, you're going to thrive. And if you don't, you're not going to. The question boils down to fundamentally the point I made earlier is giving everybody that basic access first before we even start talking about, massifying the use of AI, in the world. But I think what I want to do is close now. We promised at 1 o'clock, so we've got Craig. Can you have some last words? And thank you very much, all panelists. I don't want to give you time to round off because I'm just scared that this thing will shut us down just now. But thank you all very, very much, and we will be in touch by email. But Craig, let's close up now.
Yep. Yeah. Thanks again, everyone. Big thank you to all our panelists for making the time from all over the world, everyone who joined us as well. For those who are interested, we're going to try some other interesting things going forward. One of the things is a little generative art competition, so if anyone wants to get involved in that. We're going to try and have some more focused webinars in some of the areas listed there. And very exciting, we're going to be doing in September a conference, which will actually be both physical and online, where we want to take this to another level, and that'll be linked to a journal. But if you want to be part of that, we've got a list there that you can join. You'll see there's a bit.ly link that you can join the email list just to stay in touch with us. And there's a couple of other projects that we've got going. There's the journal that I've mentioned as well. But yeah, we'd love you to stay involved if you want, because we try and carry this on. I think the big thing that's come out is we don't really know where it's all going, but I think the general sentiment here was it's quite positive. We think we can do amazing things. We've got to be careful. There are ethical dilemmas. There are issues about not even knowing what's inside the black box, as Bruce was talking about when we open it, how it's all going to work. But it's here. And I think one thing which has been in the media recently, some of the big tech people were saying pause. Well, I think this cat is out the box. There's no pausing this particular thing. There's no going back. So if that's not an option, what do we do going forward? Well, that's what this conversation was about, or at least starting that conversation. So again, thank you, everyone. Thank you especially to our panelists for making the time and being here for so long. I really appreciate it. And yeah, and thank you everyone who attended. We really appreciate you being here.
Yeah, and if any of the panelists want to say last few words, and you might get cut off, but but we've said our goodbyes and thank yous. But you can anybody want to say a few words?
Your final takeaway that will leave them powered.
I just think that I'm going to jump in here and say that I think it'd be great. I see Kathy Arbuckle has suggested that the next session might be on all the ethical issues And I think all of us have to have sort of touched on this, whether it be gender, racism, sexism, or the use of big data, privacy, and so on. And I think we raised so many of these issues, but we didn't really engage with them in depth. And I think you know, that would be a really nice follow-up session.
I think we will do that. Yeah. Serge, any last comments?
Not that much. So I'm just going to say good evening because it's 7 p.m. for me.
Yes, yeah. Thank you for giving up your supper time for us. Yeah. Bruce, anything from you?
No, I just want to close by saying we need to keep looking under the hood. That's to me the most important thing, and I was very encouraged by all of the other panelists as well. Thanks.
Thank you, John. Some last words for you.
I start in with the genie is out of the box and there's no putting it back. So we all have to think about how we change to adapt.
Yes.
Yeah, absolutely.
Yeah.
Bilal?
Yeah, so my takeaway is that there's always going to be two levels of discussions around AI. One is the philosophical, the more longer term discussions. What are the longer term implications? And then there are the more pragmatic short term. And I think the entrepreneurial types like myself running the smaller institutes, we are more flexible to sort of focus on what is now. We're not too concerned whether AI is going to destroy the human race or not. It's in the meantime, how do we use AI?
Make money.
Until then.
It works. Yeah. Absolutely. Listen, from my side, I want to say to the panelists, I know some of you had, I tracked you guys down and I hounded you and I know you're busy, but John, thank you very much. You've given up some time for us. Serge for stepping in for Marwala. I contacted Silija, your vice chancellor, rector, who I know. He couldn't make it, so he asked you to step in, and thank you for that. And Bruce, I know how busy you are.
Thank you.
We can never get hold of you, but yeah, thank you very much.
He's in the black box.
This was a great use of my time. Thanks.
I hope you guys enjoyed it, and I hope the audience enjoyed this. There are some very strong comments, especially about the ethics and gender neutrality, etc. These are hard issues. I can discuss mathematics and IT all day. Ethics and the other side, things are all very. You can sit and look at all these men on the screen now, and I feel a bit guilty. But that's not, these are issues we have to deal with. Perhaps the next session, Craig, would be on ethics and AI. It's something that we could do, and we'll think about this. We've sent out a link in the chat to people to please, if there's a sheet, we'll put it on the website as well, so you can go and click on it. I think it's on the website, Craig. If it's not, we can put it there. Please give us your permission to contact, with the Data Protection Acts in Papua, we need your permission to be able to contact you, to be able to give you updates on what's going on. So give us your permission, we'll do that. If you don't, that's fine. You can check our website. But yeah, watch the space and let's see how we can get this space moving. Right. Thank you very much. Have a nice day.
Have a great day. Cheers, everyone. Bye.
Thank you.
Bye.
Have a good day. Bye-bye.
Thanks. Bye.